Chinese have announced that they're going to go to the moon. In fact, they will probably beat the United States.
China has announced plans to go to the moon, and they might even arrive before the United States. Last year, NASA admitted their schedule is behind China's. With China's intention to visit the moon, they will likely surpass the USA. In fact, NASA acknowledged they're lagging behind China in timing. Did you know that China's remarkable discovery on the moon was revealed by the well-known physicist Michio Kaku? Yes, you heard that right. In this video, Michio Kaku unveils China's amazing lunar findings and takes you on a space adventure like never before. What could be this month's surprising discovery? How will it change how we think about the universe? After people of color land on the moon, a station will be built around it. Join us as we explore the cosmos in search of answers to these pressing questions and the fascinating secrets at the moon's core. An incredible journey awaits you. Strange spring water source on the moon. Our closest space neighbor, the moon, has always been a mystery. But recent unexpected discoveries by Chinese scientists are starting to answer some of the biggest questions. Just 2 years ago, China sent a robotic spacecraft to the large dark region of the moon that's visible from Earth, called the Ocean of Storms, or Oceanus Procellarum. The spacecraft, named Chang'e 5, landed near a large peak on the moon. What's most exciting? For the first time in almost 50 years, a spacecraft returned to Earth with samples from the moon. The last time this happened was during the Soviet mission in 1976. Many scientists thought that when the moon formed around 4 billion years ago, heat caused all the water to evaporate, but that wasn't the case. There's actually a lot of water on the moon, frozen into ice. This ice is usually found near the moon's poles, which are always dark. NASA plans to send astronauts there because future missions will benefit from having access to this water. Let's explore this remarkable phenomenon. Chang'e 5 found more than just water. It brought back almost 60 ounces of rock and soil samples rich in rare minerals like helium-3 and others. But that's not all. Before returning to Earth, Chang'e 5 used onboard instruments to take measurements suggesting that water might exist on the moon's surface. So where does this water come from? Some scientists think there might be hidden water on the moon, while others believe it was brought there by meteorites. According to reports from Chinese and European probes, the answer might be found in lunar samples taken from the moon's northwest by China's Chang'e 5 mission. These samples contain tiny glass beads in various colors that look like small pearls. How did they get there? Maybe the heat from meteorites striking the moon formed them. What's most satisfying is that these tiny beads have water lines on them. Yes, you read that correctly. There is water on the moon. Scientists from the Chinese Academy of Sciences have shown that for every ton of lunar soil, there are about 2,000 grams of water in these crystals. Interestingly, because the moon has been hit by meteorites throughout its history, these glass beads can be found all over the moon, from the equator to the poles. Although most of the water on the moon is thought to be in the form of hydroxyl groups, there are still water molecules present. It's estimated that these glass beads could hold up to 270 billion tons of water. In 2010, NASA calculated that the moon's Arctic craters held about 600 million tons of ice, but this new finding suggests there's even more. The best part is that we couldn't have predicted the depth of existence this water could offer. The lunar samples brought back by Chang'e 5 aren't as large as those from the US Apollo program or Soviet missions. Recent studies suggest that the meteorite impact that occurred 2 billion years ago, similar to the one that wiped out the dinosaurs 68 million years ago, produced the glass holding these pearls. One might wonder how water gets into moon crystals. It turns out our sun might be responsible. Scientists believe that hydrogen atoms from the solar wind penetrate the glass beads and mix with oxygen. The beads release some hydrogen when heated by the sun, which is crucial to the moon's water cycle. So these glass beads are more than just water. They also play a role in regulating the moon's orbit. This revelation is about to change how we identify places on the moon. Scientists are now exploring the possibility that water on the moon could support human life during long-term missions far from Earth. A research team from the Chinese Academy of Sciences thoroughly evaluated the results. Were they able to find it in the Chang'e 5 data? There are signs of open water. Scientists use spectral reflectance, a measurement of how a material reflects sunlight, to detect H2O molecules. The implications are vast. According to Matt Siegler, a senior scientist at the Planetary Science Institute in Tucson, Arizona, there might be more water on the moon than we previously thought. This is a far cry from the barren wasteland the Apollo astronauts reported in 1969. The idea that the moon was dry started to crumble. India's Chandrayaan-1 mission discovered signs of hydration on the moon's surface. However, it was unclear if this was water or hydroxyl, a chemical similar to a cleaning agent. Later studies, according to NASA postdoctoral researcher Casey Hannibal, revealed the presence of ice in shadowed craters near the moon's poles. Water molecules trapped in glass beads and minerals caused scientists to rethink the original Apollo findings. Is this water actually from the moon or Earth? What happened? NASA was preparing an announcement 1 month before China's Chang'e 5 found water on the moon. They claimed that the moon contained water. They were observing from a height of 45,000 feet. Yes, you read that right. NASA uses the Stratospheric Observatory for infrared astronomy to collect water molecule signals at specific wavelengths. These findings raise the hopeful possibility that there might be more water on the lunar surface than previously thought, and that it might last longer than the ice at the poles. While earlier research indicated the presence of water, China's latest lunar landing was the true game changer. Geologist Matt Siegler notes that to calculate the amount of water present, the resulting spectral reflectance data needs to be properly corrected for temperature. Determining an object's temperature from far away is a challenge. This is what makes Chang'e 5's mission unique. By landing on the moon, it can measure temperature precisely and remove uncertainty. However, don't expect to see lakes or bubbling streams on the moon just yet. Interestingly, Chang'e 5 discovered a small pool of water in an area known as Oceanus Procellarum that was hidden beneath the lunar surface. Scientists think this water might have come from the sun's solar wind, a stream of charged particles. When the solar wind, rich in hydrogen atoms, strikes the oxygen in the moon's rocks and soil, water is created. Remarkably, more water is visible in the same region of lunar rocks, suggesting another unknown water source, rare moon crystal. But the story doesn't end there. Scientists made another astounding discovery, a unique lunar mineral that could potentially power the entire planet. Rivaling NASA, the China National Space Administration has gained media attention for its achievements in space exploration. They built a station, launched several missions, and made significant discoveries, the latest of which stunned the scientific community. So, what's Michio Kaku's moon idea? In 2020, crystals were found in lunar basalt grains composed of a substance science had never seen before. This substance contains essential elements for nuclear fusion, which powers our sun and stars. After analyzing samples from the lunar surface, researchers from the Beijing Institute of Uranium Geology discovered a new lunar mineral. China is now one of the few nations, along with the US and the former USSR, to have found new minerals on the moon. This is because the Chang'e 5 mission successfully returned over 1.7 kilograms of lunar samples to Earth, the first lunar sample return mission since 1970. The Beijing Institute named the new mineral Changesite, after Chang'e, the moon goddess in Chinese mythology. Let's talk about the Chang'e 5 mission robot responsible for this remarkable discovery. 46 years after its previous lunar material collection, it launched from Hainan province and returned to Earth carrying 1,731 grams of lunar rocks and soil. This mission, one of China's most challenging to date, was an exciting 23-day journey. After successfully retrieving the samples, they were divided into 21 groups and distributed to researchers in 13 different labs for 31 research projects. With this achievement, China gained recognition in space exploration history, joining the US and the former Soviet Union as the third nation to collect lunar data. Numerous organizations contributed to the research, including the Ministry of Natural Resources, the Ministry of Education, and the Chinese Academy of Sciences. Even though the small pebbles found on the moon are just slightly larger than a human hair, they offer scientists opportunities they never imagined. One remarkable element found in crystals formed during the moon's volcanic activity around 1.22 billion years ago is helium-3. Michio Kaku had to break the news to the public because it was such a huge surprise. Chinese ground teams awaited the landing of the unmanned mission. You might wonder, what's so special about helium-3? The Chang'e 5 lunar research mission returned over 140,000 lunar particles, and among them, scientists found traces of helium-3, a rare and potentially valuable material. Although uncommon on Earth, this form of helium is thought to be abundant on the Moon because it was deposited there by the solar wind thousands of years ago. What does this discovery mean? Helium-3 nuclear fusion is considered a fuel source that could revolutionize how we produce clean, efficient energy on Earth. Scientists have long regarded helium-3 as a potential nuclear fuel. Just like how stars get their energy, nuclear fusion occurs when two light atoms combine at high temperatures to form a heavier atom. Here's a quick physics refresher. So far, we haven't been able to replicate a strong reaction that generates more energy than we use. What makes helium-3 a good candidate for this marvel? Helium-3 is different because it produces less waste and generates more energy, making it a clean and safe energy source. Currently, nuclear fission is used in our power plants to generate energy, but it creates waste containing uranium, plutonium, and other elements. In the long run, if we can switch from fission to fusion using helium-3, we'll have a safer, more efficient, and cleaner way to produce nuclear energy. Although competition for lunar resources has increased with the discovery of helium-3, we still need a reliable generator to fully use its potential. China and the United States are among the nations and companies interested in mining helium-3 on the Moon. Chang'e's discovery of fresh helium-3 reserves will intensify competition for lunar resources, bringing us closer to a future where lunar materials are a reality, not just science fiction. When we look at the Moon, we don't just see our celestial neighbor, we see the pure energy light of our future. According to scientists, this element could provide energy for nuclear fusion reactors in ways we don't yet understand on Earth. But wait until you hear about the Chang'e 6 mission scheduled for 2024, which aims to collect the first samples from the Moon's far side, permanently hidden from our view. It's too soon to estimate the cost of this resource, but it will undoubtedly be expensive. There's a catch. We'll need more moon crystals, especially if we want to create powerful fusion reactors. Doesn't that sound like the plot of a new sci-fi movie? It gets even more intriguing, so hold on. You might be surprised to learn that, for an estimated $3 billion per ton, 25 tons of helium-3, the size of a parking lot, could power the entire United States for a year. This discovery may spark a space race between nations and companies looking to extract helium-3 from the Moon, revealing bizarre new developments. Remember Chang'e 4, China's first lunar rover to land on the far side of the Moon? Launched on December 7, 2018, Chang'e 4 touched down on January 3, 2019. It also made a remarkable discovery. Let's look back at 2019. On July 28th, the rover sent a notification before its daily shutdown to avoid the midday sun. In one of the images, a scientist spotted an odd material that looked like gel and had a strange color. The rover team quickly canceled the robot's sleep schedule to investigate. They were intrigued enough by their findings to send the rover back to examine these unusual items, shifting its focus from small craters to oddly colored substances. The rover used its visible and near-infrared spectrometer to analyze the item's composition. However, the nature of this vibrant object remains uncertain in the lunar environment. Leftovers from a meteorite collision? We don't know for sure yet. This will keep specialists busy for some time. There was excitement and hope when the rover's spectrometer discovered the odd object, though we want to know more. The fact that the analysis results are still proprietary and no images are available fuels further speculation. Scientific consensus suggests this gel is actually glossy molten glass. It's believed that the shiny substance formed when meteorites struck the Moon, leaving behind a glassy surface. There are notable exceptions. Mahesh Anand, an Earth scientist at the Open University in the UK, agrees with this viewpoint but points out that it's challenging to determine the product's specific composition due to limited information. He did confirm that the substance might be a kind of glass. It could be a significant finding if this glass substance is indeed beneath the Moon's surface, especially if it includes ice. This theory was supported by another scientist from Syracuse University, who speculated that the substance might be moon dust heated by impacts and transformed into glass. After all, meteorites are one of the few factors that can alter the lunar surface, especially since other geological processes we see on Earth like wind and water, are absent. He uses the glass rock known as trinitite, created by the high temperatures of nuclear tests in New Mexico, to explain this. He thought that when meteorites struck the moon, something similar might happen. Interestingly, oddly colored patches on the moon have been observed before. Much of the lunar surface is covered by lunar regolith, a gray dust. However, in 1972, astronauts Harrison Schmitt and Gene Cernan noticed something strange during the Apollo 17 mission. The landing site had orange soil. Scientists eventually concluded that the unusual soil was caused by a volcanic eruption that happened about 3.64 billion years ago. So, is this new substance another piece of debris from a meteorite strike or something else? As the story unfolds, we eagerly await answers because the jury is still out. But that's not all. In November 2021, Chang'e 4's Yutu-2 rover discovered a house-like object. Scientists were surprised and excited to see the small square structure, nicknamed the Mystery House, up close. They moved the rover closer to find out what secrets it might hold. However, the public's perception was incorrect. The moon house is actually just an ordinary moon rock that looks like a rabbit, hence its nickname Jade Rabbit. This moon rock is a real gem that exists on Earth. It was discovered that the Mystery House illusion was created by a combination of surfaces, angles, and shadows. This fascinating finding highlights the gaps in our knowledge of celestial objects and how human senses can misinterpret them. This isn't a moon-specific illusion. Pareidolia, the phenomenon where objects or images appear in random patterns, is common worldwide. The Mystery House story illustrates the complexity and wonder of the universe, from seeing faces in clouds to recognizing shapes in rock formations, where light and shadow create illusions. It's true that there's an infinite amount waiting to be discovered on the moon as we continue to explore its secrets. From finding water and rare minerals to discovering helium-3 and studying peculiar phenomena, we move closer to solving the mysteries of our planetary neighbor and expanding our knowledge of the cosmos with every new expedition and discovery. The moon captivates our imagination and piques our interest with its breathtaking surface views and unexpected terrain. It invites us to study its mysteries and uncover its secrets as we prepare for a crewed mission on the horizon, marking the beginning of a new chapter in lunar research. So come along on an incredible journey to the moon and beyond with us. Together we'll solve the secrets of the moon, explore the wonders of the Earth, and discover the passage of time, all guided by the spirit of exploration and the desire to learn. With every new discovery, we get a little closer to solving the universe's riddles and learning about our celestial neighbors. Thanks for watching another episode. While you're here, you can watch more space-related videos.
Today says that growing light pollution is making it harder than ever to see the stars.
Stars adorn our night sky with a captivating glow, but in an unexpected and troubling development, approximately 700 trillion stars have mysteriously vanished. Naturally, this phenomenon has left scientists deeply perplexed, but this was merely the onset of a larger mystery. New entities are now emerging from the depths of space, demanding urgent understanding. Who or what is responsible for the unexplained disappearance of 700 trillion stars in our universe? Could there be a link between these vanishing stars and the unidentified objects originating from deep space? Join us in this video as we explore the enigmatic occurrences unfolding in the cosmos. Scientists are warning that over 700 trillion stars have suddenly disappeared, while something unknown is emerging from the darkness. We'll uncover possible explanations for the disappearing stars and delve into the emergence of this mysterious phenomenon. You might see something resembling a star in an old photograph, only to find it has vanished in subsequent observations. For millennia, humanity has strived to comprehend concepts like science and mathematics, tools that help us decipher our place in the universe, in the fundamental nature of our world, even as its core remains cloaked in enigma. One key principle is that matter cannot simply cease to exist, it must change form. Think about a person disappearing after falling into molten lava. The disappearance is just the final phase of a scientific process. The matter undergoes significant transformation before assuming a new form. Similarly, when a star explodes and seems to disappear, its material disperses throughout the cosmos, persisting in a different state. We mention this because a perplexing mystery has emerged in the far reaches of space, one that currently defies definitive explanation. Stars are disappearing from our night sky. At first glance, this might not seem extraordinary, given the universe's vastness, where a star's sudden disappearance can be due to various reasons, such as reaching the end of its lifespan or being consumed by a massive entity like a black hole. However, what's confounding about this situation is that the disappearing stars aren't isolated cases. They are numerous, totaling in the trillions. Recent observations reveal that over 700 trillion stars have inexplicably gone missing, leaving astronomers baffled by their abrupt absence. While a few stars vanishing might be explainable in such an immense universe, the disappearance of hundreds of trillions, especially those not at the end of their life cycles or under external threats, poses a completely different challenge. Thankfully, a group of dedicated scientists is working tirelessly to solve this cosmic puzzle. Beatrice Villaroel from the Nordic Institute for Theoretical Physics in Sweden offers insight into their mission. Our project, called VASCO, Vanishing and Appearing Sources During a Century of Observations, is our initiative. She adds, "We're fascinated by various disappearing objects, but our ultimate goal is to find a star that has consistently been in the sky throughout human history and recorded data, only to suddenly vanish without a trace. Even our most sophisticated telescopes can't detect any leftovers." It's important to understand that this isn't just a whimsical quest. The VASCO project has been active since 2017 and has attracted significant attention. Villaroel explains that the project has piqued the interest of astronomers from various specialties, including those studying active galactic nuclei, stellar physics, and even SETI scientists, each motivated by different reasons to join. The team recognizes that some aspects of the universe are unpredictable, partly due to our limited capacity to catalog every celestial body with perfect accuracy over such vast distances. Yet they remain hopeful that finding a specific type of star that suddenly disappears could lead to groundbreaking discoveries. Villaroel emphasizes the potential impact. While they are aware of variable stars whose brightness changes over years, they're searching for a star that shifts from consistent stability to complete disappearance, a phenomenon not yet observed. Discovering such an event could open up entirely new areas of physics. You might ask, is it really possible for a star to vanish without any warning? The surprising answer is yes. For example, astronomers had been monitoring a star for about 2 decades until 2019. They were intrigued by its brilliant, crystal blue light. Then, without warning, it was gone. Andrew Allen, a doctoral researcher in astrophysics at Trinity College Dublin, scrutinized the data repeatedly. Because the star was so distant, telescopes couldn't observe it directly. Instead, astronomers looked for the unique signatures that such luminous blue stars imprint on the light from their host galaxies. Shockingly, these signatures had vanished. At the time, the prevailing theory was that the star had gone supernova and turned into a black hole. However, there were no clear signs of a supernova explosion or its aftermath, nor was there evidence of a black hole. Given the interval between observations, it seemed highly unlikely that such a significant event would have gone unnoticed. Astronomer Yair Arkavi from Tel Aviv University highlighted the conundrum. If the star did become a black hole without a supernova, it represents a case of disappearing without the usual fireworks, something astronomers have been trying to understand for a long time. This suggests that some stars might directly collapse into black holes without the dramatic explosion typically expected. Hints of such events date back to 2009, when a star that had captivated many telescopes seemed to be nearing a critical point. Suddenly, it transformed into a black hole before scientists could fully grasp what was happening. While definitive evidence is still lacking, these occurrences have left astronomers searching for explanations. Equally noteworthy is the collaborative effort among various research teams to create detailed catalogs of stars and their properties. These catalogs allow astronomers to compare and analyze stars extensively using online databases. The findings have been both encouraging and astonishing. One researcher mentioned that they found numerous short-lived phenomena that appear in one image and disappear in the next, which constitutes the majority of their discoveries so far. Yet there are still other occurrences that resist immediate explanation. They've investigated some of these fleeting events and ruled out common causes like M-dwarf flares or novas. Building on this, some astronomers believe that the disappearance of these stars could be related to how light travels across the universe's vast distances. Now extend that distance across galaxies. It prompts the question of how we can see anything at all. The reason is that the countless light rays emitted by stars take an incredibly long time to reach us. When they do arrive, they mix with the light from our sun, making them visible in our night sky. The light we see is actually ancient. In the case of our sun, its constant light emission makes it visible to us every day. Yet despite its relative proximity, sunlight still takes about 8 minutes to reach Earth. When considering stars that are light years away, it's clear that the light we observe is extremely old. This is relevant because the seemingly sudden disappearance of stars might be due to the immense age of the light we're receiving. While it appears immediate to us, the star could have died eons ago, and we're only now noticing its absence. This also relates to stars that have long periods of brightness before fading beyond detection. It's a complex idea, and although unproven, these questions are essential for uncovering the truth behind these mysteries. Naturally, some people are drawn to more extreme theories. Among astronomers, one of the most intriguing hypotheses about disappearing stars involves extraterrestrial intelligence. You might wonder how aliens could make stars vanish. The idea isn't that they cause stars to disappear, but that they might be using these massive celestial bodies for their own purposes. Have you heard of the concept of a Dyson sphere? Currently a staple of science fiction, it involves an advanced alien civilization, or perhaps a future human society, building a massive structure around a star. This megastructure would capture and harness the star's energy on a colossal scale, effectively turning it into an enormous power source, or potentially even a weapon. This is reminiscent of the Star Killer base in Star Wars: The Force Awakens, which used a star's energy to destroy entire planets. However, this explanation faces significant challenges. Firstly, we have no concrete evidence of extraterrestrial life. Additionally, constructing a fully operational Dyson sphere around even a small star would require unimaginable time and technological prowess. Extending this idea to over 700 trillion stars as part of a massive galactic project seems highly improbable. Despite this, some people still entertain the possibility. So, where does that leave us? Essentially, we're left with more questions than answers. We know that something unusual is happening in the universe, causing stars to disappear from our sight. This isn't a random occurrence given the large number of missing stars we've detected. The pressing question is, what is causing so many stars to vanish in such a relatively short period? That's why many individuals and organizations across different fields are committed to solving this mystery. Finding the answers could deepen our understanding of the universe. If similar events happen in the future, we'll be better prepared to identify their causes quickly. While the enigma of disappearing stars continues, something new has been detected deep in space. Scientists have discovered enormous voids that surpass our previous expectations, reaching scales that encompass the solar system and even the Milky Way. The universe is filled with voids, vast regions where celestial objects are scarce. One such remarkable void is the Boots Void, also known as the Great Nothing. When you look up at the night sky, it seems uniformly sprinkled with countless stars. However, areas like the Boots Void are dramatically different, containing very few celestial bodies. Essentially, the universe has a unique structure composed of long filaments of dark matter intertwined with galaxies and galaxy clusters, all punctuated by these immense voids. These voids are vast, empty regions lacking in matter. To truly understand the universe, we need to explore these mysterious chasms. The largest known void in the universe is the Bootes Void. This enormous, empty, spherical region spans about 330 million light-years in diameter. That's only about 0.27% of the universe's total diameter, but it's still staggering. Located near the Bootes constellation, this void is approximately 700 million light-years away from us. Initially, only one galaxy was found within it, but a few dozen more have been discovered since. On average, these galaxies are about 10 million light-years apart, a distance 4 times greater than that between the Andromeda galaxy and Earth. This stark emptiness becomes even more apparent when compared to our local cosmic area, the Virgo supercluster. This smaller region, about 110 million light-years across, contains over 2,000 galaxies, including the Milky Way. To put the scale of this emptiness into perspective, astronomer Greg Aldrin noted that if the Milky Way were at the center of the Boots void, we wouldn't have known other galaxies existed until the 1960s. In contrast, our Milky Way is accompanied by about 24 nearby galaxies within just 3 million light-years. Given the volume of the Boots void, it should theoretically contain around 10,000 galaxies, based on the typical distances between galaxies elsewhere in the universe. Astonishingly, only 60 galaxies have been found in this vast emptiness, making them some of the loneliest galaxies known. The Hubble Space Telescope captured an image of one such galaxy, MCG plus 01-02-015, a spiral galaxy residing within the Boots void. The European Space Agency described it as the loneliest galaxy. How it ended up in such isolation is still a mystery. In the image, you can see 3 foreground stars from our own Milky Way. All other points of light are distant background galaxies, resembling tiny organisms in a drop of water. So how do these voids form? Computer models show that smaller, more common voids result from galaxies gravitating toward each other, depleting the surrounding areas. However, this process can't explain the Boots void because there hasn't been enough time since the universe began for gravity alone to clear out such an enormous space. This brings us back to the Big Bang theory. Most people might imagine the universe expanding uniformly after the Big Bang, with galaxies evenly spreading out. But when we examine the universe on the largest scales, encompassing billions of light-years, a more complex structure appears. Let's rewind to the universe's earliest moments. Shortly after the Big Bang, the universe was a dense, extremely hot plasma. Despite being mostly uniform, there were tiny fluctuations, quantum variations in space-time. As the universe expanded, these small differences in matter density became more pronounced. This led to regions of higher and lower matter density on a cosmic scale. Fast forward 13.8 billion years, and we see that these minute early variations evolved into the massive structures we observe today. These structures include enormous walls made up of thousands of galaxies, interconnected by nodes where galaxy filaments meet. These colossal formations stretch across thousands of galaxies and span hundreds of millions of light-years. The spaces, or voids, between these galaxy clusters are even larger. These voids aren't completely empty. They're just less dense than regions filled with galaxies. Their matter density is about 1/10 of the universe's average, so they still contain dark matter, gas, dust, stars, and galaxies, but in much smaller quantities. For instance, the giant void contains 17 different galaxy clusters. As the universe continues to expand, these voids, like the Boots void, will grow even larger. The walls and filaments connecting galaxy clusters will stretch and eventually break apart, leaving only gravitationally bound clusters within the expanding void. As these voids merge, the sheer size of the observable universe becomes even more astounding. Our own position in this vast cosmos is within the local group, part of the Virgo supercluster, located on the edge of a massive cosmic void. There's still so much to explore in this immense expanse. So far, astronomers have identified the largest known structure in the universe, a massive void called the supervoid. This supervoid spans an incredible 1.8 billion light-years in diameter and is notable for its extreme emptiness. It provides answers to questions that have puzzled scientists for over a decade, but also raises new ones that could hint at new physics. The amount of cosmic matter, including galaxies and dust, within the supervoid is about 20% less than in regions with typical density. While it's not entirely empty, it feels like a vast, cold wasteland compared to other parts of space. The existence of this supervoid is connected to the discovery of the cold spot, a region observed over 10 years ago for its unusual size and lower temperature than expected based on the cosmic microwave background radiation, the leftover thermal radiation from the Big Bang. Scientists have been searching for a void in this area because as photons travel through an expanding universe, they lose energy and cool when they pass through a void. Confirming this area's extremely low density would help explain why the cold spot exists. This phenomenon occurs because photons convert their kinetic energy into gravitational potential energy as they move from denser regions toward the center of a void. This energy conversion leads to a temperature drop, causing the light to leave with a longer wavelength in a cooler temperature. To find out how many galaxies are in a region about 3 billion light-years from Earth, Istvan Sapudi from the University of Hawaii and his team, including Andras Kovács from Eötvös Loránd University in Budapest, took on the challenge. They used the Pan-STARRS-1 telescope in Hawaii and NASA's Wide Field Survey Explorer satellite. Their research revealed that the cold spot does exist within a large, sparsely populated region. While the structure might not stand out as unique, it's remarkable given the typically uniform distribution of matter at this scale in the cosmos. Unfortunately, only about 10% of the temperature difference between the cold spot and surrounding galaxies can be explained by the supervoid. Returning to the Bootes void, it wasn't until the discovery of dark energy in 1998 that scientists found a possible explanation. Dark energy is a mysterious force that causes empty spaces to expand, as if the entire universe is inflating all at once. Many astronomers believe that these puzzling regions, which reveal the universe's underlying structure, could be key to the next major discovery. There's a growing effort to catalog and map these voids to measure dark energy, gravity, and any unexpected new forces more precisely by statistically analyzing their shapes. Moreover, recent evidence suggests that these vast, nearly empty regions dominating the universe might be accelerating its expansion. This means that dark energy, the mysterious force thought to be pushing the cosmos apart, could be linked to these enormous voids. Essentially, the universe is expanding every day, growing larger with each passing second. This accelerated expansion phase, which seems to have started about 5 billion years ago, remains a mystery to astronomers. Dark energy is just a term we've given to this colossal cosmic puzzle. So what's the connection between dark energy and these cosmic voids? One major reason is that the effects of accelerated expansion aren't noticeable within star systems or galaxies, because the gravitational pull of matter is too strong. Dark energy hasn't caused the Milky Way or our solar system to expand. However, since cosmic voids have very little matter, they're much more susceptible to the influence of dark energy. Therefore, it makes sense to study this accelerated expansion where its effects are most pronounced. A recent study suggests that dark energy might not only be present in voids, but could actually result from them. This leads to the intriguing question of how these vast empty regions might be causing the universe to expand more quickly. Thank you for joining us for another episode on our channel. While you're still here, click on the video on your screen to discover more mind-blowing space content like this one.
Well, that's the problem. The James Webb Space Telescope is upsetting the apple cart. All of a sudden, we realize that we may have to rewrite all the textbooks about the beginning of the universe.
On a cool evening in early October, the JWST sent ripples through the global scientific community by detecting a mysterious signal originating from the Andromeda galaxy, the closest major galaxy to our own Milky Way. For decades, humanity has gazed at the stars, searching for signs of extraterrestrial life or phenomena that defy natural explanations. While we've uncovered countless cosmic wonders, new stars, planets, black holes, and even promising hints of habitable worlds, the discovery of this alarming signal from Andromeda marks a significant turning point in our comprehension of the cosmos. Before we delve deeper, don't forget to like and subscribe for more exclusive updates. Michio Kaku. As soon as the signal was detected, global attention shifted to Michio Kaku, the esteemed theoretical physicist and futurist renowned for his work on string theory and his enthusiastic support for space exploration. Kaku has long argued that the quest to find extraterrestrial life isn't merely a scientific endeavor, but a fundamental question about what it means to be human. Are we truly alone in the universe? The reception of this enigmatic signal from Andromeda might finally start to answer that profound question. The James Webb Space Telescope, a marvel of modern technology, was designed for multiple purposes: to peer deep into the universe's past by observing the earliest light from galaxies formed billions of years ago, to search for exoplanets, and to provide detailed information about the atmospheres of these distant worlds. However, no one anticipated that it would become a beacon for potentially intelligent signals from a neighboring galaxy. Located approximately 2.5 million light-years from Earth, the Andromeda Galaxy is a familiar celestial neighbor, often considered a twin to the Milky Way. Despite this proximity, the vast expanse between our galaxies has made astronomers cautious about expecting any clear signs of intelligent life beyond our own. When the JWST detected the signal, its characteristics immediately raised eyebrows. It wasn't merely electromagnetic radiation from natural stellar sources like pulsars or black holes, which are known to emit repetitive signals. Instead, the frequency and structure of the Andromeda signal suggested something far more intentional. The patterns were too orderly to dismiss as random cosmic noise. To add to the intrigue, the signal repeated at intervals that resembled structured, coded communications. This could potentially indicate the presence of intelligent life capable of creating and transmitting signals across immense cosmic distances. In his public addresses, Kaku explored the possible ramifications of such a signal. Firstly, he emphasized the monumental scientific significance of its detection. If the signal indeed originates from an advanced civilization in Andromeda, it would represent a historic moment for humanity. For centuries, we've looked up at the sky, wondering if we are the sole intelligent species in the cosmos. Discovering evidence of intelligent life in another galaxy would suggest that life isn't a rare occurrence, but perhaps a likely outcome of the universe's natural processes. The Drake equation, long used to estimate the number of intelligent civilizations in our galaxy, might require serious reevaluation. The signal from Andromeda could imply that the universe is teeming with life in ways we hadn't previously imagined. Implications. The implications extend far beyond science and astronomy. They touch on philosophy, sociology, and even theology. For Kaku, the philosophical dimension is unavoidable. Humanity has long operated under the assumption that Earth is unique, and by extension, that we hold a special place in the cosmos. Detecting an intelligent signal from Andromeda challenges this deeply ingrained belief. It raises profound questions about our species' future. Are we on the path to making contact with another civilization? If so, what could that mean for our cultural, technological, and social development? Might we be considered a primitive civilization in comparison? More unsettling is the possibility that the signal comes from a civilization with technology far surpassing our own. Kaku also pointed out that while the signal is thrilling, it carries potential risks. He referred to the well-known concept in the search for extraterrestrial intelligence called the dark forest theory. This theory posits that intelligent civilizations might choose to remain silent to avoid attracting the attention of more advanced, possibly hostile species. If the Andromeda signal is a deliberate message, it could be a plea for help, a declaration of existence, or, more ominously, a warning. If we're receiving their communication, it suggests they either don't subscribe to the dark forest theory or are unaware of its potential dangers. This brings us to an immediate concern. What should humanity do next? Should we respond? Kaku has been an outspoken advocate for caution. Reaching out to a civilization millions of light years away isn't without significant risks. Even if the signal is benign, any reply we send would take millions of years to reach Andromeda. By the time our message arrives, the senders might have evolved beyond recognition or ceased to exist. The vast timescales involved create a paradox where entire civilizations could rise and fall on both sides before any meaningful exchange occurs. The technological achievement of detecting such a signal is itself extraordinary. The JWST wasn't specifically designed to search for extraterrestrial communications, making this discovery even more remarkable. It raises questions about how many other signals we might have missed from more distant galaxies. What if other signals have gone undetected because of our technological limitations? Kaku often stresses the importance of investing in more advanced space observation technologies. While our current tools are impressive, they are just the beginning. To fully comprehend the universe and potentially communicate with distant civilizations, we'll need even more sophisticated telescopes and observational arrays. This discovery could accelerate developments in this direction, prompting space agencies like NASA and private enterprises to expedite their plans for new space-based instruments. However, the detection of this signal also brings up concerns about how the international community will manage such a monumental finding. Until now, space exploration has been largely collaborative, with nations working together to expand our collective knowledge. The prospect of contacting another civilization might, however, introduce a new level of competition. Countries might rush to be the first to decode the signal, claim the prestige of first contact, or leverage the event to assert dominance in space exploration. Kaku cautioned that humanity must avoid repeating past mistakes. History is filled with examples where competition and distrust between nations have led to conflict. He advocates for a unified, collective approach, emphasizing that this discovery belongs to all of humanity, not any single nation or organization. The true nature of the signal remains unclear, and deciphering it will likely take years or even decades of meticulous analysis. There's still the possibility that it could be a natural phenomenon we do not yet understand. Kaku and other scientists remain open to all possibilities, advising against hasty conclusions. However, if this signal is indeed from an intelligent civilization, it could serve as an invaluable learning opportunity. Even if we can't decode the exact message, understanding its structure might provide insights into how other intelligent species communicate. It could introduce us to entirely new concepts in mathematics, language, and science that we haven't even conceived of yet. Moreover, the signal might be a form of communication so advanced that our current knowledge can't fully grasp it. Just as ancient civilizations couldn't detect radio waves because they lacked the necessary technology, the Andromeda signal might be part of a broader, more sophisticated system that exceeds our current capabilities. This possibility fascinates Kaku, suggesting that our civilization is still in its infancy on the cosmic scale. We might be like children overhearing a complex conversation, able to pick out certain words but missing the full context. The future of humanity could depend on developing the tools and intelligence needed to engage with these advanced forms of communication. The journey ahead. One of the most exciting possibilities Kaku raises is that this signal might not be unique. He theorizes that other signals could be hidden within the cosmic background noise, awaiting discovery. Given the vastness of the universe, it's highly unlikely that Andromeda is the only galaxy harboring intelligent life. If one civilization can send a signal, others might have already done so. The detection of the Andromeda signal could be the first in a series of discoveries that radically reshape our understanding of the universe and our place within it. The prospect of receiving a signal from an intelligent species in Andromeda opens a new chapter in human exploration. While the challenges are immense, the potential rewards are equally significant. Kaku's enthusiasm is infectious, but his call for caution is well-founded. The path ahead requires careful thought, balancing ambition with prudence, and maintaining an openness to whatever truth the cosmos may reveal. Whether this signal leads to first contact or simply enhances our understanding of the universe, it marks a pivotal moment in scientific history. It's a moment that will be remembered for generations, igniting the imaginations of dreamers, explorers, and scientists alike. As we stand on the brink of one of humanity's greatest discoveries, private companies and space agencies worldwide might feel inspired or compelled to accelerate their plans. Enterprises like SpaceX, Blue Origin, and others could seize this opportunity to advance their space initiatives, possibly pushing for the development of more sensitive instruments capable of detecting signals from even greater distances. The ultimate aim would be to equip humanity not just to detect signals, but to communicate effectively across intergalactic spaces. Achieving this would require advancements in quantum computing, artificial intelligence, and radio astronomy, as well as breakthroughs in propulsion technology if we ever hope to explore the signal source directly. Another significant consequence of this discovery involves the moral and ethical questions it raises. What rights and responsibilities do we have when interacting with another intelligent species? If the Andromeda signal is a deliberate attempt at communication, it opens up ethical debates that philosophers and scientists have pondered for centuries. Should we respond? If so, how should we go about it? What form would our response take? Intergalactic communication presents unique dilemmas. For one, we don't know the signal's intent. It could be a friendly greeting, an observation, a warning, or something entirely beyond our understanding. There's also the issue of whether humanity is prepared for such a discovery. Historically, encounters between advanced and less technologically developed societies on Earth have often resulted in adverse outcomes for the latter. Could humanity find itself as the less advanced civilization in this cosmic encounter? Kaku frequently points out that our technological sophistication might be rudimentary compared to an intergalactic civilization. What if this civilization is billions of years ahead of us? They might regard us with the same curiosity and detachment that we have when studying microorganisms. This notion raises uncomfortable questions about intelligence and power dynamics in the universe. He often refers to the Kardashev scale when discussing potential hierarchies of civilizations. This scale measures a civilization's technological advancement based on its energy consumption. Currently, humanity is a Type 0 civilization, relying solely on planetary resources. A Type 1 civilization can harness all the energy of its home planet, a Type 2 can utilize the energy of its entire star, and a Type 3 can command the energy of an entire galaxy. If the Andromeda signal comes from a civilization that's Type 2 or 3, it challenges us to consider how such an advanced society might perceive us. The technologies they possess, artificial intelligence, faster-than-light communication, perhaps even interstellar travel, could defy our current understanding of physics. While this could lead to a renaissance of scientific discovery on Earth, it could also provoke fear and paranoia. History shows that fear of the unknown can lead to irrational actions. On a cultural level, this discovery could prompt a period of deep introspection. It forces us to confront existential questions that have lingered for millennia. Why do we exist? What is our role in the universe? Are we meant to join a larger galactic community, or are we destined to remain isolated observers? If the signal originates from an intelligent species, it might offer insights into how another civilization has addressed these fundamental questions. They may have overcome challenges like war, inequality, and environmental degradation, providing a model for how humanity might evolve. Conversely, their experiences could serve as a warning about the pitfalls of unchecked technological progress. Political implications. Religious and spiritual communities around the globe are likely to feel the impact of this discovery profoundly. Many belief systems posit that humanity holds a unique place in the universe, possibly as the sole intelligent life. The possibility of other intelligent beings, especially ones far older and more advanced, could challenge foundational doctrines. How will different religions reconcile the existence of extraterrestrial intelligence with their teachings? This could lead to a crisis of faith for some, while others might find that it expands their understanding of the divine. The discovery also opens up philosophical debates about consciousness and the soul. If other intelligent beings exist, what is the nature of their consciousness? Do they possess self-awareness, emotions, a sense of morality similar to ours? Or are they fundamentally different in ways we can't yet comprehend? Politically, the Andromeda signal could have far-reaching consequences. Governments worldwide would likely scramble to interpret the signal and control the narrative. International organizations like the United Nations might become forums for intense debate about the appropriate course of action. Should humanity unite to decode the message and decide on a response, or will nations pursue their agendas? The discovery could either foster unprecedented global cooperation or exacerbate existing tensions, particularly among superpowers with advanced space capabilities. Countries might compete to be the first to decode the signal, hoping to gain technological or strategic advantages. This could lead to a new kind of space race, not just about exploration, but also about securing potential benefits from any new technologies derived from the signal. National security concerns would also come into play. Governments would need to consider the risks of responding. Could acknowledging the signal make us vulnerable to hostile extraterrestrial forces? The militarization of space, already a concern, could accelerate as nations invest in defense systems against hypothetical threats. National security implications. The economic implications are equally significant. The burgeoning space economy could receive a substantial boost as both governments and private companies invest in technologies to detect, decode, and possibly respond to extraterrestrial communications. New industries could emerge, focusing on interstellar communication technologies, advanced propulsion systems, and more sophisticated space exploration tools. Intellectual property resulting from decoding the Andromeda signal could become a highly valuable asset. Universities, research institutions, and private companies might engage in fierce competition over patents and proprietary technologies. This could spur innovation, but also lead to legal and ethical disputes over ownership and access to these advancements. However, this rapid expansion into space brings risks. There could be unintended consequences like environmental harm to other celestial bodies or increased militarization of space. Ethical considerations about exploiting extraterrestrial environments would become more pressing. Beyond these immediate concerns, the signal invites us to ponder the nature of life and intelligence in the universe. What kind of intelligence could have sent this signal? It's possible that the signal doesn't come from biological beings, but from artificial intelligence created by a civilization that may no longer exist. Kaku and other futurists have speculated that advanced civilizations might reach a point where they can upload their consciousness into machines, achieving a form of immortality. If the signal comes from such a machine intelligence, it challenges our understanding of life itself. Another intriguing possibility is that the signal represents an attempt at interstellar diplomacy. Perhaps a civilization in Andromeda is part of a larger coalition of intelligent species spread across the universe, and this signal is an invitation to join them. This concept, a staple in science fiction, edges closer to reality with this discovery. However, integrating into a galactic community poses its own challenges. How would humanity, with its myriad political, religious, and cultural differences, present a unified front? Would we be accepted as equals, or might we find ourselves subordinate to more advanced species? As the world grapples with the implications of this signal, the event continues to push the boundaries of our knowledge and imagination. Each day brings new discussions, research avenues, and speculative theories. Scientists, technologists, and thinkers are deeply engaged in contemplating the long-term effects of this potentially transformative moment. The complexity of the signal and the vast array of possible explanations force us to reevaluate our assumptions about our place in the universe. One of the most immediate questions is what kind of intelligence could have sent this signal? Our understanding of intelligence is limited, based largely on our own species. We tend to project human cognitive and social traits onto hypothetical alien civilizations. But what if the intelligence behind the Andromeda signal is so different from ours that it's almost incomprehensible? This possibility is one of the most fascinating aspects of the discovery. If the signal is artificial, it might represent a form of intelligence operating under entirely different biological, cognitive, or technological frameworks. Communicating with such an entity would be an unprecedented challenge. The diversity of life on Earth provides only a hint of what's possible. Even among Earth's species, there are vastly different ways of processing information and perceiving reality. Dolphins use echolocation, bees communicate through complex dances. The intelligence behind the Andromeda signal might utilize forms of communication that are entirely alien to us, perhaps involving dimensions of physics we have yet to discover. This leads to the crucial task of language and decoding. Historically, breaking language barriers between human cultures has been a significant hurdle. Decoding a message from another species, potentially from another galaxy, presents an exponentially greater challenge. Scientists like Kaku speculate that we might start by identifying universal constants, such as mathematical principles or physical laws, as a common language. For example, sequences of prime numbers or patterns like the Fibonacci sequence could serve as initial points of connection, given that mathematics is considered a universal language. However, even this assumes that the other intelligence perceives the universe in a way that's compatible with our own understanding. Our efforts to decode the signal will likely rely heavily on advanced artificial intelligence and machine learning technologies. The complexity of the patterns might be beyond human cognitive capabilities, necessitating sophisticated algorithms to identify and interpret potential meanings. Training AI to simulate various alien cognitive models could expand our ability to make sense of the data. As we undertake this monumental task, the question of whether to respond looms large. Some experts advocate for caution, suggesting we should focus on understanding the message fully before deciding on any course of action. Others argue that the chance to engage with an advanced civilization is too significant to delay, despite the risks. The decision to respond ties back to the issue of trust. We cannot assume that an extraterrestrial civilization shares our values or even has a concept of values that we can recognize. Establishing common ground might be one of humanity's greatest challenges. Kaku and others suggest looking to our history for guidance, But human encounters between disparate societies have often resulted in exploitation and conflict. This historical context underscores the need for a cautious and ethical approach. This is where the idea of cosmic humility becomes vital. Recognizing that we may not be the most advanced beings in the universe can be both humbling and inspiring. It opens the door to learning and growth, potentially accelerating our scientific and technological development. The Andromeda signal may also compel us to reassess our notions of progress. If we encounter a civilization that has evolved along a different path, perhaps prioritizing sustainability or social harmony over technological dominance, it could challenge our assumptions about what it means to advance. Simultaneously, the signal acts as a mirror, reflecting our unresolved issues back at us. Global challenges like climate change, inequality, and geopolitical tensions demand our attention. How can we aspire to engage with an advanced alien civilization when we're still grappling with problems here on Earth? The discovery might serve as a catalyst for uniting humanity to address these pressing concerns. In terms of international relations, crafting a response to the signal would require unprecedented global cooperation. A message to another galaxy represents all of humanity, necessitating a collective effort to define what we want to communicate about ourselves. The cultural impact of the discovery is immense. It could inspire a new wave of creativity across art, literature, and media as we explore what it means to be human in a universe potentially filled with life. Educational systems might adapt to include new disciplines focused on astrobiology, extraterrestrial communication, and interstellar diplomacy. If you found this discussion intriguing, please like and subscribe for more insights. We'd also love to hear your thoughts. What do you think the signal from Andromeda could be? Share your ideas in the comments below. Thank you for joining us, and we'll see you next time. Since its launch in 2021, the James Webb Space Telescope has sparked a persistent question in the minds of the public. It's a question that ignores the wealth of data about ancient galaxies or the formation of stars and focuses on just one thing. When will the JWST find evidence of alien life? Surprisingly, this question isn't as far-fetched as it might seem. NASA has long prioritized the search for extraterrestrial life. Whether it's a microbial fossil buried in Mars's ancient lake beds or a simple organism in Europa's hidden ocean. However, while the Mars and Europa missions remain largely speculative, the JWST could be on a much faster track. It might even discover signs of alien life as early as next year. In September, researchers using the JWST made a potentially groundbreaking discovery in the atmosphere of the exoplanet K2-1b. They found promising indications of both water and a molecule that could be linked to life. With follow-up observations planned for 2024, we may be on the verge of a major breakthrough. However, as we will soon explore, many planetary scientists remain skeptical of these findings. A skepticism that touches on one of NASA's toughest modern challenges: how we can ever be certain that we've truly discovered alien life. Among the array of discoveries made by the JWST, this one stands out as particularly significant, possibly the most important to date. On September 12, 2023, a research team from the University of Cambridge, led by Professor Niku Madhusudan, released the results of their recent observations of K2-18b. This exoplanet, located about 120 light-years from Earth in the constellation Leo, has intrigued scientists since 2019, when the Hubble Space Telescope detected potential water vapor in its atmosphere. That initial finding prompted the Cambridge team to turn the powerful JWST towards K2-18b, though what they ultimately discovered exceeded all expectations. The findings revealed both methane and CO2 in K2-18b's atmosphere, along with an absence of ammonia. National Geographic explained that according to theoretical models, a large planet like K2-18b could only have that mix of gases if the atmosphere was interacting with water below. The possibility that K2-18b might be an ocean world, one covered by a sea far greater than anything on Earth, was already a thrilling prospect. However, Professor Madhusudan's research took it even further. In addition to methane and CO2, the JWST detected dimethyl sulfide, DMS, a molecule typically linked to life. As the Cambridge professor told the BBC, on Earth, DMS is only produced by life. Most of it in our atmosphere comes from phytoplankton in marine environments. While the team emphasized that the DMS detection was of low confidence and more observations are required, the notion of alien plankton was hard for many to ignore, and understandably so. NASA is currently engaged in a decades-long mission to discover non-terrestrial life. The Mars Sample Return mission alone is investing over $8 billion to retrieve material from the red planet in hopes of finding signs of ancient microbial life. Meanwhile, next year, the Europa Clipper, with a budget of $5 billion, will set off on its journey to Jupiter's water moon to investigate whether it could theoretically support living organisms. This is why the possibility of the JWST detecting a known biosignature in the atmosphere of an exoplanet is so captivating. Dreams that perhaps some were too eager to embrace. But we'll get into the reasons to be skeptical a bit later in this video. Right now, we need to cover a few crucial points for everything else to make sense. First, what exactly is K2-18b? And second, how do we even begin to detect anything in its atmosphere, given that it's such an incredibly distant planet? After all, it's really far away. To answer these questions, let's embark on a little journey through the cosmos, leaving Earth behind, gliding across the vast expanse of space until we arrive in a distant solar system about 120 light-years from home. This solar system is where one of the most fascinating exoplanets ever discovered resides. The straightforward answer to the question, what is K2-18b, is rather simple, though the finer details remain somewhat unclear. At its core, K2-18b is an exoplanet situated more than 120 light-years away, falling into the category known as sub-Neptunes. This means it is larger than Earth but smaller than Neptune. Specifically, it has a radius roughly 2.6 times that of Earth, a size range that does not exist in our solar system. This unique classification makes it challenging for scientists to theorize about what K2-18b might truly be like. For most rocky exoplanets, we expect them to be similar to Earth or Mars. When we look at distant gas giants, we anticipate that they will have something in common with Jupiter or Saturn. But sub-Neptunes? Well, there's nothing in our solar neighborhood to draw comparisons with. As the saying goes, scientists are fumbling in the dark, like a blind man at an orrery. We do, however, know enough about K2-18b to make some informed assumptions. For instance, we are aware that it orbits its parent star, a red dwarf referred to as K2-18 within the habitable zone. This means that if water were theoretically present on its surface, it would be in liquid form, similar to the conditions found on Earth. However, it doesn't orbit at the same distance from its star as Earth does from the Sun. While the distance between our Sun and Earth is 1 astronomical unit, AU, K2-18b is much closer to its star, at only 0.16 AU. In our solar system, that would be significantly nearer than Mercury. It is so close, in fact, that a year on K2-18b would last only 33 days. Its proximity is such that if it were orbiting our Sun, the intense heat would scorch its surface beyond recognition. Fortunately for any potential space plankton on K2-18b, its star is significantly cooler than our own. So cool, in fact, that the two could almost embrace without instantly turning any surface water into vapor. And this is a crucial detail because, according to recent theoretical studies, surface water might be a defining characteristic of planets like K2-18b. In 2021, Professor Niku Madhusudan, the very scientist whose team may have identified DMS, released a fascinating paper in the Astrophysical Journal about the makeup of sub-Neptunes. In its simplest form, his claim was that these planets might harbor an entirely new class of exoplanets, ones encased in massive oceans beneath hydrogen-rich atmospheres. He has since dubbed these planets Hycean worlds, a term blending hydrogen and ocean. If they exist, these water worlds could be completely unlike anything humanity has ever come across. With up to 10 times the mass of Earth and twice its radius, they would be intensely hot, reaching temperatures as high as 200 degrees. Even with this extreme heat, the main feature of these Hycean planets wouldn't be a barren, steamy void, but rather a vast layer of water surrounding a small rocky core. A colossal ocean that could make up as much as 90% of the planet's entire mass. This ocean, at least theoretically, might be capable of supporting basic microbial life. Moreover, the thick atmospheres on these worlds would offer a much wider zone of habitability around their parent stars compared to rocky planets like Earth. It's similar to how Canadians manage to walk around in t-shirts in temperatures that would leave most of us shivering. Given the large number of sub-Neptunes that we know exist, coupled with this broader habitable zone, Hycean worlds could be prime candidates for finding life, especially since larger planets are, as you would imagine, easier to observe from a distance. This is why Madhusudan's team decided to use the JWST to peer across the vast expanse of space at K2 and 18b, a move that might, just might, soon lead to confirmation of the existence of Hycean worlds. However, as we're about to explore, this is no simple task. Even with the immense capabilities of the JWST, detecting ocean worlds is extremely complicated. In January and again in April of 2023, the JWST focused on the star K2-18 for a total of 5 hours. These 5 hours were divided into 2 separate blocks, each lasting 2.5 hours. During this time, K2-18b crossed in front of its parent star, and as it did, the star's light passed through the planet's atmosphere. It was the light captured by the JWST that enabled Madhusudan's team to draw their conclusions about the atmospheric composition. As the BBC detailed, that light holds the chemical signature of the molecules within the atmosphere. By splitting the light into its component frequencies, much like how a prism creates a rainbow spectrum, the details can be deciphered. If certain parts of the spectrum are absent, it means they have been absorbed by specific chemicals in the planet's atmosphere, thus allowing researchers to determine its composition. This is the method we use to uncover which molecules exist on distant planets. However, it's far from a simple matter of glancing at the spectrum and exclaiming, "Oh, look, aliens!" Every detection comes with something scientists refer to as a sigma value. For the rest of us, a sigma value is essentially a measure of how confident researchers are that what they've detected isn't just a fluke or an embarrassing mistake. To give an example, if something is detected with a 1 sigma signal, it means there's a pretty decent chance the molecule you're looking at is as real as that high school girlfriend who supposedly lived in Canada. A 2 sigma signal is a bit more believable, like a guy bragging about how much weight he can lift. Plausible, but still maybe not entirely true. Once you reach 5 sigma, though, you're dealing with something that's almost certainly real, like the fact that I'm bald. At that point, disproving it would take some seriously strange circumstances. In general, the scientific community won't fully accept a discovery unless it hits at least a 3 sigma threshold. Anything below that is seen as too shaky to rely on. For K2-18b, the JWST detected methane in the atmosphere with a 5 sigma confidence level, meaning we can be virtually certain it exists. On the other hand, the detection of CO2 came in at a confidence level of 3 sigma. This is less certain, but still probably reliable enough to be accepted by the scientific community for the time being. However, one thing the JWST did not detect, with any meaningful confidence at all, was water vapor. The water vapor that Hubble had supposedly found back in 2019 turned out in the 2023 results to have been a false reading caused by methane instead. Madhusudan's team is excited about the possibility that this planet could be a Hycean world because the combination of molecules found in its atmosphere aligns with the theoretical model for such a world. However, this doesn't confirm the presence of an ocean. As JAXA's astrophysicist and science communicator Elizabeth Tasker put it in a blog post, "We have not discovered water on K2-18b. All we can say is that the planet does not have an ocean." If this kind of cautious language sounds frustrating, well, that's the reality of how science operates. While it would be fun to dive into the excitement of distant ocean worlds, our responsibility is to follow the approach taken by serious astrophysicists and remain cautious when discussing Hycean planets. This measured approach is especially critical for the most thrilling aspect, the possibility that the JWST has detected a molecule linked to life. Early next year, the JWST is expected to once again focus its powerful instruments on K2-18b. Over the course of the 2.5 hours that the planet transits in front of its star, Professor Madhusudan's team will attempt to strengthen confidence in some of their previous findings. seeking more solid proof that a global ocean truly exists, and once more trying to detect that life-signaling molecule, DMS. Webb's mid-infrared tools, which are specially designed to search for evidence of DMS, will assist in this effort. Given that confirming this could suggest the presence of alien organisms, there is naturally a great deal of excitement. However, this excitement will be tempered with extreme caution for one significant reason. The original DMS detection, which generated numerous articles, including this very video, was not very reliable. In fact, it had a sigma value of only 1, about as plausible as the infamous girlfriend from Canada. Excuse. As planetary scientist Joanna Barstow kindly explained to Chemistry World magazine, it is a very tentative detection. Still, even a low-confidence detection of something that might indicate extraterrestrial life deserves closer scrutiny. Proving the existence of space plankton would truly be one of the most extraordinary discoveries ever, demonstrating that life evolved independently from Earth at least once, implying it may have done so dozens or even hundreds of other times throughout the universe. Unfortunately, though, even if the JWST delivers a 5 sigma value detection of DMS next year, we still can't just jump up and shout, "Woo, space creatures, yay!" First, scientists would need to eliminate any possible natural, non-living explanations for the molecule's presence. While DMS on Earth is indeed linked only to life forms, that might not hold true on K2-18b. The key reason? Hycean worlds, if they exist, would be so fundamentally different from anything we've ever seen that we can't make any assumptions. When someone like our channel pops up on your YouTube talking about ocean worlds, you're probably thinking, "Oh, cool, just like that Kevin Costner movie." In that case, you're likely picturing a planet similar to Earth, just minus all the land. But in reality, Hycean worlds are much stranger than that. Astrophysicist Ethan Siegel wrote an insightful article on Big Think that explains the difference. In his analysis, any planet with over twice the mass of Earth and a radius exceeding 1.3 times that of our planet cannot be a rocky world like Earth. Moreover, any planet with a radius greater than 1.75 times that of Earth ends up resembling Neptune far more than it does our homeworld. Neptune, in fact, is an extraordinary place, an intriguing world where diamonds rain down and atmospheric pressures reach levels so high that NASA has described it as creating a hot, dense fluid of icy materials and an ocean of superheated water. This Neptunian ocean exists far beyond normal boiling points, but remains liquid due to the immense pressure. However, it is completely uninhabitable, a brutal landscape that would obliterate any known form of life faster than a game of beer pong played with cyanide. If K218b has an ocean, it could very well be something similar. Siegel discusses planets of similar size, stating that if a hydrogen-helium atmosphere constitutes even 0.5% of the planet's total mass, the surface pressure will be tens of thousands of times greater than what we experience on Earth, with temperatures soaring into the thousands of degrees. This means K218b cannot be an ocean-covered world akin to Earth. And therein lies a major issue. If K218b is so vastly different from Earth, we cannot automatically assume that an Earth-based biosignature, like DMS, similarly indicates Earth-like life on this distant exoplanet. To quote Elizabeth Tasker once again, we need a lot more information about conditions on that planet to be sure that a biosignature on Earth could not be abiotically created in a different environment. Such studies have not yet been done for K218b or Hycean worlds in general. That quote concludes, "Now it's clear that a great way to advance such studies would be for someone to confirm the presence of DMS in K218b's atmosphere. Therefore, the JWST searching for it next year remains an incredibly exciting endeavor. However, it also implies that the likelihood of detecting alien life may be further off than we initially hoped, particularly when considering all the other potential issues associated with Hycean planets." Let's go back to September 2020, during the height of the pandemic, when the monotony was interrupted by a rather spectacular news event. As the world was in the grips of lockdown, a team of scientists reported detecting a molecule in Venus's upper atmosphere, one that was thought to signal life. What followed was a massive media frenzy, with many declaring that we might have discovered Venusian space organisms. Even today, some still believe NASA's selection of 2 Venus probes for its next discovery mission, announced shortly after, was influenced by the phosphine discovery. Fast forward to 2023 and the consensus among scientists is clear. We don't have solid evidence of phosphine in Venus's atmosphere. While it might still be present, the 2020 findings were far from robust enough to justify the high-profile announcements that followed. This is a key reason why caution is being exercised around DMS on K2118b. However, other factors contribute as well, including significant theoretical challenges with Hycean planets. One major issue is the likelihood of runaway greenhouse effects. Due to the high levels of hydrogen in their atmospheres, Hycean worlds would interact with sunlight in ways that are vastly different from Earth. Recent studies have demonstrated that if such a planet had Earth-like atmospheric pressure and orbited at a similar distance from its star, its oceans would quickly overheat and evaporate. To maintain liquid water, a Hycean planet would need to orbit much farther from its star, beyond Mars, past Ceres, and all the way past the asteroid belt's edge. Only at around 385 AU could a typical Hycean world, with atmospheric pressures 10 times that of Earth, manage to retain an ocean. The main issue, we haven't identified any Hycean world candidates within this new, extended habitable zone. That includes K218b. Even though its star is significantly cooler, the planet is likely still too close to support liquid water. And even if an ocean were confirmed, that wouldn't guarantee the presence of life. In fact, the planet might not be habitable at all, largely due to the immense pressure created by the sheer mass of water in a global ocean. To quote expert Elizabeth Tasker once more, "A vast global ocean exerts such immense pressure on the planet that it suppresses the geological activity forming under high-pressure conditions. Deep sea ice would form and effectively seal off the rocky layers of the planet, thereby, at a minimum, halting the carbon silicate cycle. If the carbon silicate cycle stops, then other mechanisms must step in to regulate greenhouse gases, maintaining a habitable temperature and delivering the necessary nutrients typically sourced from silicate rocks. Without these nutrients, life forms would have nothing to sustain them, nothing to spark the chemical processes essential for life to emerge. Although it's possible, in theory, that meteorites could introduce sufficient nutrients into the ocean, it's equally possible that Hycean planets, if they exist, are simply barren water worlds. We won't really know until we get to observe one up close and truly understand what's going on there. All of which is our very long and drawn-out way of explaining that while the detection of DMS on a water-covered exoplanet is undeniably exciting, it's unlikely to confirm the existence of extraterrestrial life, at least not anytime soon, and certainly not without a significant amount of additional research. And honestly, this isn't the outcome we were hoping to share with you when we began working on this video. We'd much rather be here saying that we're about to uncover the scientific proof of bizarre space creatures. But as the saying goes, extraordinary claims require extraordinary evidence. And as we've shown, the presence of DMS alone may not be enough to support that claim. However, this doesn't mean we have to end this video on a negative note. Whether or not aliens are involved, the exploration of K208b remains incredibly fascinating. Thanks to the JWST, we are now, for the very first time, beginning to understand the different types of planets that exist in our universe. Giant worlds far larger than Earth are waiting to be explored. Planets whose mysteries we are gradually uncovering, one observation after another. These worlds could ultimately prove to be uninhabitable nightmares. Or perhaps the Hycean worlds theory is correct, and we're actually surrounded by a multitude of thriving oceanic planets. The key takeaway here is that we won't know for sure without carefully studying these distant realms. Whether or not signs of life are eventually found, Professor Madhusudan's team is performing a crucial service by starting to break down these cosmic mysteries. In doing so, they open the door to the possibility that in the near future, another scientist will take a reading with the JWST and indeed find a biosignature, finally announcing to the world, yes, it's aliens. We can only hope that day comes sooner rather than later. We hope you enjoyed this journey through space, And if you did so, we would really appreciate you hitting the like button. For more content like this, feel free to subscribe to A World to Discover. While you're still here, go ahead and watch more from our channel by clicking the videos on your screen right now. Apollo 11's mission to the moon on July 20th, 1969 was one of the most significant events in human history.
To achieving the goal, before this decade is out, of landing a man on the moon and returning him safely to the Earth.
Astronauts Neil Armstrong and Buzz Aldrin became the first humans to set foot on the lunar surface.
It's one small step for man, one giant leap for mankind.
While Michael Collins orbited above in the command module. This achievement symbolized human ingenuity and determination. However, Buzz Aldrin has long intrigued the public with his comments about the moon. Over the years, he has hinted that the moon may not be exactly what we think, sparking curiosity and speculation about its mysteries. Aldrin's views on the moon often venture into the unusual. The second man to walk on the lunar surface, Aldrin has openly discussed his experiences during the mission. While most see the moon as a barren, lifeless satellite, Aldrin has implied there's more to it. His reflections range from personal experiences to broader thoughts on what the moon might represent for humanity, challenging the conventional view of the moon as a cold, rocky body and suggesting that its mysteries are far from fully uncovered. During the Apollo 11 mission, Aldrin and Armstrong conducted experiments and collected samples to bring back to Earth. However, Aldrin has hinted in interviews that their time on the moon may have revealed phenomena not fully disclosed to the public. Though his comments are often vague, they suggest the moon could harbor unknown phenomena, leaving room for speculation and imagination about what was truly observed during the first lunar landing. Aldrin often emphasizes the sense of awe and mystery he felt on the moon, describing it as an otherworldly place. His experience seemed to go beyond the typical overview effect astronauts describe, implying the moon may hold deeper meaning or secrets. His reflections evoke a mystical quality to the lunar surface, defying simple scientific explanation. Aldrin's comments also raise broader questions about humanity's place in the universe. For millennia, the moon has inspired mythologies, religious beliefs, and scientific inquiry. Aldrin suggests that the moon's significance might extend beyond its role as Earth's satellite, hinting at mysteries yet to be understood, potentially reshaping our understanding of the cosmos and our role in it. This resonates with the idea that the moon symbolizes the unknown, a reminder of the mysteries still beyond human comprehension. One intriguing aspect of Aldrin's perspective on the moon is what might lie beneath its surface. While the Apollo missions, including Apollo 11, provided valuable data, much of the moon's interior remains a mystery. Some scientists believe the moon could reveal clues about the solar system's formation, and Aldrin's musings suggest it may hold more than geological secrets, perhaps hidden structures, ancient artifacts, or other unknown phenomena. Aldrin has also fueled speculation about extraterrestrial activity. He once mentioned seeing an unusual object during the Apollo 11 mission, later clarifying it was likely part of the rocket, but the incident added to the mission's mystique. The moon's unique position in Earth's orbit, being unusually large and nearly perfectly circular, has led some to theorize it might be an artificial object created by an advanced civilization. While Aldrin hasn't endorsed this idea, his open-mindedness toward the moon's mysteries leaves room for speculation. Aldrin sees the moon as a crucial stepping stone for future space exploration. He has long advocated for continued lunar exploration and using the moon as a base for missions to Mars and beyond. Aldrin believes humanity's future lies in space, and establishing a permanent presence on the moon is essential, not just for scientific reasons, but also as preparation for further space travel. To him, the moon is both a mystery to solve and a gateway to the broader cosmos. Aldrin's respect for the unknown drives his curiosity about the moon, believing much remains undiscovered. He encourages humanity to keep exploring and questioning what we know, aligning with the spirit of pushing the boundaries of space exploration. For him, the moon is the frontier where humanity might confront the unknown and uncover extraordinary discoveries. Recently, Aldrin has stressed the need for renewed space exploration, especially as Earth faces global challenges. He believes the moon could help address these issues by serving as a platform for scientific research, resource extraction, and even habitation. His reflections on the moon's mysteries suggest that some of the answers to pressing human challenges may lie not on Earth, but on the moon and beyond. The implications of Aldrin's views on the moon are profound. If the moon is more than just a barren rock, as Aldrin implies, it could reshape our understanding of the universe and our place in it. The possibility that the moon holds hidden secrets, whether ancient artifacts, unknown geological formations, or signs of extraterrestrial activity, challenges the conventional narrative of space exploration and raises questions about what we truly know about our closest celestial neighbor. Aldrin's reflections encourage a re-evaluation of humanity's relationship with space. While space exploration has traditionally been driven by scientific curiosity, technology, and geopolitical competition, Aldrin suggests deeper philosophical reasons to continue exploring. The moon, in his view, symbolizes the unknown and reminds us that mysteries in the universe remain to be uncovered. This perspective calls for a more holistic approach to space exploration, considering not just the scientific and technological aspects, but also the broader implications for humanity's future. As NASA's Artemis program aims to establish a sustainable presence on the moon, Aldrin's reflections gain more significance. This new era of lunar exploration could provide answers to some of Aldrin's questions and reveal new mysteries. The possibility that the moon holds more than we previously thought adds excitement and intrigue to upcoming missions. It also reminds us that despite technological advancements in space exploration, profound questions about the universe remain unanswered. Aldrin's fascination with the moon stems from his first-hand experience of walking on its surface, which significantly shaped his worldview and led him to question established understandings of our natural satellite. While most focus on the triumph of Apollo 11, Aldrin's reflections emphasize the strangeness and mystery of the experience. His perspective suggests the moon may hold more significance than we realize, challenging our knowledge and inviting deeper exploration. Aldrin's insights indicate the moon may not be just a barren, lifeless rock, but something much more enigmatic. Aldrin's comments often suggest that the moon could be a key to understanding deeper cosmic mysteries, possibly linked to our understanding of space, time, and the origins of life. One major question raised by Aldrin's reflections is the moon's origin. While the prevailing theory is that the moon formed from debris after a giant impact between Earth and another planetary body, some aspects of its composition and behavior remain unexplained. For example, certain elements on the moon's surface do not fit neatly into this hypothesis, leading Aldrin to speculate that unknown processes may have influenced its formation. Aldrin has also expressed intrigue over the moon's gravitational relationship with Earth. While its role in stabilizing Earth's axial tilt in controlling tides is well known, Aldrin has suggested that this relationship might be more complex than we currently understand. The moon's orbit and its influence on Earth raise questions about whether an unknown force may govern these interactions, inviting further exploration of how celestial bodies affect one another in ways that might still be unexplored. Aldrin's interest in the moon is strongly connected to his curiosity about extraterrestrial life. While he has never claimed to have seen aliens or found direct evidence of their existence, his open-mindedness about space's mysteries often leads to speculation. The moon, being Earth's closest celestial body, is seen as a potential starting point for discovering life beyond our planet. Aldrin has suggested that if extraterrestrial life exists, it might have left traces on the moon, such as artifacts or subtle signs not easily detected. This makes the moon a significant target for future exploration. Aldrin's reflections also show his willingness to consider unconventional ideas, including the possibility that advanced civilizations visited the moon long before humans. Though speculative and lacking evidence, his open-mindedness encourages exploration of these ideas to deepen our understanding of the moon's history. Aldrin has speculated that the moon could serve as a hub for future human expansion into space. He has long advocated for permanent lunar bases to support missions to Mars and beyond, making the moon a critical stepping stone for humanity's future in space. His reflections weave together two ideas: The moon holds unexplored mysteries, and it plays a vital role in humanity's continued exploration of the cosmos. Aldrin's Apollo 11 experience instilled in him a sense of wonder and humility, seeing the moon as a symbol of the unknown, urging humanity to push the boundaries of knowledge and capabilities. A recurring theme in Aldrin's reflections is the potential for life beyond Earth. While the moon is unlikely to harbor life, its proximity to Earth and role in space exploration make it a key location for studying conditions that could support life elsewhere. Aldrin has suggested that the moon could be a laboratory for experiments to help understand the origins of life on Earth and other planets. Studying the moon's geology and solar interactions could offer clues about life's emergence in the universe. Aldrin is also interested in the moon as a platform for studying Earth and the cosmos. Its lack of atmosphere and stable position make it ideal for astronomical observations. He has advocated for building lunar observatories to study the universe in ways not possible from Earth, highlighting the moon's potential to unlock the mysteries of the universe. The idea of the moon serving as a base for human activity raises important questions about resource utilization. Aldrin has often discussed the potential for mining the moon's resources, particularly helium-3, a rare isotope that could be used for future energy production. Although this presents significant technical and ethical challenges, the possibility of supporting human exploration and development in space has intrigued Aldrin for decades. He emphasizes the need for careful planning and international cooperation to use these resources responsibly and sustainably. Aldrin is also optimistic about humanity's future in space. He believes that while space exploration poses challenges, they are not insurmountable. His Apollo 11 experience instilled in him confidence in human ingenuity and perseverance. For Aldrin, the moon is both a challenge and an opportunity, a place where humanity can test its limits and move forward into new frontiers. His reflections often emphasize that the moon, while mysterious and sometimes daunting, symbolizes hope and humanity's potential for great achievements. Beyond its scientific and exploratory significance, Aldrin has suggested the moon could help foster global unity. The Apollo 11 mission was a triumph for all humanity, not just the United States. Aldrin frequently speaks of the awe and wonder people worldwide experience watching humans set foot on another world. He believes future lunar missions could unite nations in pursuit of common goals, making the moon not just a scientific frontier, but a place where humanity collaborates toward a shared future. Aldrin's reflections emphasize the importance of preserving the moon's environment. Though a strong advocate for human exploration and development, he stresses the need for careful stewardship of the moon's fragile ecosystem. Its barren surface holds vital clues about the solar system's history, and Aldrin warns against damaging or disrupting this natural environment. His views highlight the balance between exploration and preservation, a critical theme as humanity's presence in space grows. Aldrin also believes the moon could serve as a training ground for future spacefarers. Its harsh conditions, low gravity, lack of atmosphere, and extreme temperatures provide an ideal environment for astronauts to develop skills and technologies for missions to Mars and beyond. He advocates for lunar training facilities, aligning with his vision of using the moon as a stepping stone for further exploration. Additionally, Aldrin sees potential in space tourism and commercial ventures on the moon. With companies like SpaceX and Blue Origin advancing space travel, he envisions partnerships between governments and private industry, making the moon a destination for tourists as well as scientific exploration. This idea builds on the growing trend of space commercialization, where private companies are increasingly taking on roles traditionally held by government space agencies. Aldrin envisions a future where private enterprise plays a key role in making the moon accessible, creating new opportunities for economic development and human experience. Beyond tourism, Aldrin sees the moon as a platform for advancing space-based manufacturing and technology development. The moon's low gravity and lack of atmosphere offer unique conditions for testing technologies such as space habitats, energy production, and resource extraction. He has emphasized the moon's potential as a testing ground for technologies critical to future Mars missions, including advancements in life support systems, radiation shielding, and habitat construction. all of which could be refined on the moon before being used for longer missions to Mars or beyond. Aldrin's interest in technology focuses on the long-term sustainability of human activities on the moon, particularly through renewable energy sources like solar power. The moon's lack of atmosphere and extended sunlight make it ideal for generating solar energy, which could power lunar bases and support human habitation. Aldrin has suggested that lunar solar power could also meet Earth's energy needs, transmitting energy back to Earth via microwave or laser beams. This concept, though early in development, could help address global energy demands and reduce reliance on fossil fuels. He also believes the moon's resources, such as helium-3 for fusion energy, could play a crucial role in solving challenges like climate change and resource depletion. While fusion energy technology is still being developed, Aldrin sees the moon playing a key role in providing clean, sustainable energy for future generations. His reflections also emphasize the importance of international cooperation in the exploration and utilization of lunar resources, stressing that the moon belongs to all humanity. Aldrin advocates for international frameworks to ensure responsible use of space resources, similar to the treaties governing Antarctica, to prevent conflicts and ensure equitable sharing of benefits. He frequently highlights the idea of space as a global commons and views space exploration as a shared human endeavor that transcends borders and political divisions. This perspective is especially relevant as more countries and private entities join space exploration. Aldrin advocates for international cooperation, believing that the challenges of exploring and using the moon and other celestial bodies are too vast for any one nation or organization to handle alone. He envisions countries working together, sharing knowledge, resources, and expertise to benefit all of humanity. Aldrin also emphasizes long-term thinking over short-term, politically driven decisions. For him, the moon offers a chance to lay a foundation for future exploration that will benefit both current and future generations of astronauts and spacefarers. He believes today's decisions on how we explore and use the moon will significantly impact humanity's future in space. Therefore, he supports a long-term, strategic approach prioritizing sustainability, cooperation, and responsible resource use. Aldrin's focus on long-term thinking ties closely to his belief in inspiring the next generation of scientists, engineers, and explorers. Throughout his career, Aldrin has passionately advocated for STEM education, often emphasizing the need to inspire young people to pursue careers in science and space exploration. He sees the moon, with its mysteries and potential, as a unique opportunity to capture the imagination of future generations. By pushing the boundaries of our knowledge and continuing to explore the moon, Aldrin hopes to inspire young people to dream big and contribute to advancing human knowledge and exploration. Aldrin's reflections on the moon also carry a spiritual dimension, often overlooked in discussions of space exploration. Though a man of science, Aldrin has acknowledged the profound awe that comes with seeing the universe from space. He often describes walking on the moon as both a scientific and deeply spiritual experience. For Aldrin, the moon symbolizes our connection to something larger, a reminder of the vastness of the universe and our small yet significant place within it. This sense of wonder is central to his reflections, underscoring that exploring celestial bodies isn't just about data or resources, but expanding our understanding of the universe and ourselves. This spiritual aspect also informs Aldrin's views on the ethical responsibilities of space exploration. He emphasizes the need for humility and respect, recognizing that we are venturing into parts of the cosmos we don't yet fully understand. Aldrin believes that as we explore the moon and beyond, we must act as stewards of the universe, avoiding harm to the environments we encounter or exploitation of resources that could negatively impact future generations. This view reflects a deep respect for the unknown and the potential for space exploration to reshape our understanding of the universe and ourselves. Aldrin's thoughts on the moon intersect with his broader interest in human evolution and survival. He has spoken frequently about humanity's need to expand beyond Earth to ensure long-term survival. For Aldrin, the moon is the first step, a place to develop the technologies and skills needed to thrive in space. The challenges of space exploration, he believes, will push humanity to evolve, both technologically and in understanding what it means to be human. Thus, the moon is not just a destination, but a catalyst for human evolution, testing our limits and preparing us for the next phase of cosmic exploration. Aldrin's vision of the moon as a stepping stone is also tied to his interest in space colonization. He advocates for permanent human settlements on the moon as a way to ensure humanity's continued presence in space. These settlements, he believes, could serve as bases for future missions to Mars and beyond, providing the infrastructure necessary for long-duration space travel. Aldrin's vision of lunar colonization isn't just about survival, though. It's also about expanding human civilization into new frontiers. He envisions a future where humans live and work on the moon, creating societies that reflect the diversity and creativity of humanity. In addition to colonization, Aldrin believes the moon could play a key role in scientific discovery. He frequently speaks of its potential as a base for studying the cosmos, conducting experiments, and pushing the limits of human knowledge. The moon's unique environment, lacking an atmosphere and close to Earth, makes it ideal for scientific research, particularly in astronomy, geology, and biology. Aldrin envisions the moon becoming a hub for global scientific discovery, drawing researchers from around the world to unlock the universe's secrets. If you like this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us what surprises you expect from this reveal. We want to hear from you. Thanks for watching, and see you next time.
Professor Albert Einstein, who helped discover the atom bomb.
What do you put the chances of having found life?
So we have the observations, they're beaming in right now. So we're waiting for the data to come to us, and the analysis will start anytime.
Scientists have reached a significant milestone in the search for an interstellar home. In a surprising discovery made by the James Webb Space Telescope, they found a new planet with properties strikingly similar to Earth. Experts are now speculating that this planet could be the ideal home away from home and may already host extraterrestrial life. However, in the midst of this excitement, researchers in the scientific community stumbled upon yet another planet that could be even more suitable for humans than Earth. What are these newly discovered planets, and where were they found? What attributes lead experts to believe these planets are suitable for human life? What are the chances of finding intelligent extraterrestrial life on them? Stay tuned, as NASA has just uncovered a new planet better for life than Earth. With the growing threats of global warming, climate change, pandemics, and natural disasters, scientists believe Earth is slowly approaching a point of no return. It's only a matter of time before a catastrophic event could wipe out humanity. In light of this, researchers have been searching for a new planet in the cosmos that could serve as our next home, much like Earth. Initially, the search focused on planets within our solar system that could potentially support human life. This led the scientific community to send probes to various planets throughout the mid and late 1900s. Because Jupiter and Venus were too close to the Sun, the best options were narrowed down to Mars, Jupiter, Saturn, and Uranus. However, it became clear later that none of these planets would be suitable for human life. Jupiter's weather is extremely unstable, making it the most unpredictable planet in our solar system. Saturn's atmosphere is rich in hydrogen and experiences helium rain, while Uranus lacks oxygen, making it impossible for humans to breathe there. The most promising candidate so far is Mars. Although Mars is dry, arid, and prone to dust storms and radiation, experts like Elon Musk remain optimistic about making it habitable. Plans to establish a base on Mars are already in progress, but creating such a base would be challenging. It would require replicating Earth's conditions, including oxygen, gravity, water, temperature, and air pressure. The cost of such an endeavor would be astronomical, amounting to billions or trillions of dollars. It would be far easier to find a planet with the right conditions elsewhere in the universe rather than transforming Mars into a habitable one. As a result, scientists have expanded their search beyond our solar system, exploring distant regions of space to identify a planet like Earth, or perhaps an even better one. To streamline the search for a suitable replacement, scientists developed the Earth Similarity Index. This index evaluates planets using factors like temperature and atmospheric pressure to determine how closely they resemble Earth and whether they could support life. The scale runs from 0.0 to 1, with higher numbers indicating a closer match to Earth. For instance, a planet with a similarity index of 0.9 would be nearly identical to our planet. With significant technological advancements, scientists have been able to explore the deepest regions of the cosmos, revealing promising candidates for human habitable planets. Among these are exoplanets and moons with striking similarities to Earth. One notable discovery from 2019 is the planet Teegarden B, one of the closest potentially habitable planets, situated about 12.4 light-years away. Its mass is 1.05 times that of Earth, making it almost identical in size. Teegarden B orbits an M-type star, Teegarden, a red dwarf. These stars are relatively cool, with surface temperatures below 3,600 Kelvin. The Teegarden star in particular is much smaller than our Sun, with a temperature around 2,700 Kelvin. Despite its low heat, the red dwarf provides enough warmth for its planets, Teegarden B and Teegarden C. Teegarden B orbits its star at a distance of 0.252 astronomical units, while Teegarden C, the other planet in the system, orbits at 0.04 astronomical units, completing its orbit in about 11 days. Both planets share characteristics with Earth, notably being located in the habitable zone of their star. This zone refers to the distance at which liquid water could exist on the planet's surface. If too far, the water freezes, too close, and it evaporates. For example, Neptune has frozen water due to its distance from the Sun, while Venus lacks water altogether, even in its atmosphere. Earth, however, is at the perfect distance for life. The discovery of Teegarden B and C indicates Earth isn't unique in this regard. Teegarden B stands out with a promising score of 0.95 on the Earth Similarity Index, ESI, which means it's nearly 100% similar to Earth. However, uncertainties remain regarding air pressure and temperature, with estimates ranging from 0 to 50 G. If its atmosphere is Earth-like, its surface temperature could be around 28 G. Teegarden C, being farther from the star, is more likely to be too cold. Experts believe it has only a 3% chance of a warm surface temperature and suspect its atmosphere may resemble Mars, with temperatures near 47 degrees Celsius. Its ESI score is 0.68. Currently, researchers don't know much about the atmospheres of Teegarden B and C, as both are tidally locked to their star. Scientists estimate their atmospheres could be 13 to 17 times denser than Earth's. There's plenty of speculation about these two planets, with some believing they could be future homes for humanity if Earth faces a catastrophic event. On the other hand, many scientists are also exploring the possibility of extraterrestrial life on these planets. For centuries, we've questioned whether we are alone in the universe. This mystery has driven both astronomy and cosmology. Despite extensive research, no alien civilizations have been found. No stars or planets have yet exhibited the ideal conditions to support extraterrestrial life. The planets that are thought to be viable for life are those with the right temperatures, atmospheres, and those situated in the habitable zones of their stars where water can exist. Water is essential for any living organism. As the saying goes, water is life. Scientists have long recognized that wherever water is present in the universe, life can likely be found. This is why planets such as Teegarden B attract significant attention when researchers search for planets that might harbor alien life. But Teegarden B isn't the only planet of interest. Other planets are also considered strong candidates for supporting extraterrestrial life. One planetary system in particular is seen as even more promising than Teegarden, the TOI 700 system. Located in the constellation Dorado, this star system contains 4 planets, with 2 of them residing in the star's habitable zone. The standout planets are TOI 700D and TOI 700E. Both planets have masses comparable to Earth's and feature rocky surfaces. TOI 700E is approximately 95% of Earth's size, with an orbital period of 28 days, while TOI 700D is about 105% the size of Earth, completing its orbit in 37 days. What makes the TOI 700 system particularly intriguing is its age, around 1.5 billion years. That puts it just a few billion years younger than our solar system, which is about 4.6 billion years old. According to cosmic timelines, 1.5 billion years is more than enough time for life to develop and evolve on a planet. Some experts believe that Tuai 700e and 700d could host rich biospheres. If these planets have atmospheres warmer than Earth's, they could not only be suitable for us but also for alien species with similar biological traits. If we were to find life on these planets, it would likely resemble the life forms found on Earth, as we tend to look for biological traits that are familiar to us. However, this is all speculative at this stage. Until we can closely study these planets' atmospheres, surfaces, and environmental conditions, we may never truly know what kinds of life forms they might host, if any at all. It's possible that planets scattered across the cosmos could house similar life forms, shaped by the same fundamental principles of biology. But there is still so much about the vast universe that remains beyond our comprehension. The potential for completely different evolutionary paths driven by conditions that are unlike anything we've encountered adds an even greater layer of mystery. For instance, the principles of evolution could function very differently on other planets compared to Earth. Evolution, like gravity, is thought to be a universal process. The concept of evolutionary convergence suggests that unrelated species can develop similar traits when they face comparable environmental challenges. Consider species like crocodiles, which have evolved to swim and breathe underwater. If similar creatures existed on water-dominated planets, they too would evolve to adapt to underwater environments. However, their evolutionary paths might differ. While some aquatic animals have developed gills to extract oxygen from water, others have not, relying on different adaptations for survival. Similarly, birds, insects, mammals, and other airborne creatures have evolved various methods to take to the skies, each suited to their specific needs. Birds, for example, soar by flapping their wings, generating the lift they need to remain airborne, while mammals like flying squirrels use a different approach, gliding gracefully by stretching out their loose skin to create a makeshift parachute. Every creature has its own unique way of conquering the air, whether it's through flapping, gliding, or hovering. It's highly likely that this incredible diversity of flight and movement is also unfolding on other planets with biolife scattered throughout the universe, where alien species have evolved their own specialized adaptations to navigate their environments. There is also a possibility that some of these planets could evolve complex biolife forms. These advanced life forms would be entirely different from anything we've encountered on Earth. Environmental conditions like temperature, atmospheric pressure, and water availability could heavily influence how these organisms evolve, driving them to adapt in ways that seem strange to us. Scientists are keeping their minds open to the idea of discovering biolife that defies our current understanding. On Earth, some organisms exhibit bizarre traits and have adapted to survive in extreme environments, from the deepest parts of the ocean to the hottest volcanic vents. These extraordinary life forms, known as extremophiles, can thrive in conditions that would be lethal to most other species, such as extreme temperatures, high radiation, or toxic chemicals. Their unique adaptations make them valuable models for the kinds of alien organisms that might exist on other distant planets with similarly harsh or unusual conditions. So far, most searches for extraterrestrial life have centered around planets with close similarities to Earth, focusing on finding life as we know it. However, studying extremophiles helps us imagine how life could evolve in radically different environments, expanding our understanding of where life might exist in the cosmos. But what if we change our perspective? Instead of limiting our search to life as we know it, we could widen the scope and explore the possibility of life that's fundamentally different. Life as we don't know it. After all, given how little we truly understand about the vast complexities of the universe, it's not unreasonable to consider that extreme biolife forms could be thriving on planets we've dismissed as uninhabitable. These planets may endure intense radiation, have an excess of particular elements, experience extreme temperatures far beyond what we consider survivable, or face severe, relentless weather. Yet in these harsh and hostile environments, there may exist life forms perfectly adapted to not just survive, but to flourish in conditions that would be unthinkable for organisms like those found on Earth. A few years ago, astronomers identified a new type of planets known as hen exoplanets, which may have the potential to support life. These planets are significantly larger, hotter, and covered with oceans, providing them with a wider habitable zone compared to Earth. Some of these exoplanets experience atmospheric pressures as high as 200 XU. They meet important criteria, including having substantial amounts of water. However, due to the extreme conditions, any biolife that might exist on these planets would be very different from the life forms we are familiar with. One fascinating example from this category is planet K2-18b. Discovered in 2015, it is one of the numerous planets found by NASA's Kepler Space Telescope. The Kepler Space Telescope, launched by NASA in 2009, was designed to search for Earth-sized planets orbiting stars within nearby regions of the cosmos. Named after the astronomer Johannes Kepler, the telescope was placed in a heliocentric orbit, meaning it orbits the Sun while gradually drifting farther away from Earth as it continues scanning the universe. Thanks to Kepler, scientists determined that approximately 25 to 50% of stars visible in the night sky likely have small rocky planets, much like Earth. Kepler's findings included multiple planets located within the habitable zones of their parent stars, and K2-18b is one such planet. Situated roughly 124 light-years from Earth in the constellation Leo, this planet is reminiscent of a mini Neptune orbiting a dim red dwarf star. Researchers suggest that planets like K2-18b could harbor life due to their potential to contain biomarker molecules. These molecules, often remnants of organic processes, can be detected in soil and water samples by space rovers or in the atmosphere through telescopes and orbiters. Common biomarker molecules include methyl chloride and dimethyl sulfite. In some cases, planets may have elements such as oxygen, methane, or hydrogen as predominant components. Earth's life forms are carbon-based, as carbon is the dominant element on our planet. If a planet lacks carbon, life forms there could have a radically different structure. For example, life forms based on hydrogen would be unrecognizable to us, especially when viewed through the lens of our own biochemistry. Planets like K2-18b are rare because they share the same key biomarker as Earth, carbon. The James Webb Space Telescope, or JWST, has revealed the presence of carbon molecules alongside traces of methane and carbon dioxide on this planet. This discovery positions K2-18b at the forefront of Earth-like planets with the potential to support biolife. Kepler K2-188b isn't the only noteworthy planet. Another intriguing but debated candidate is TRAPPIST-1b, discovered in 2016. This planet is about 1.5 times larger than Earth, and data indicates it may be capable of supporting life. According to NASA astrophysicist Thomas Green, TRAPPIST-1b has a thick atmosphere that helps protect its surface from excessive heat or radiation. However, the planet orbits much closer to its star than Earth does to the Sun, receiving far more light. The JWST has found that TRAPPIST-1b's daytime temperatures exceed 200 degrees, making it lethal for humans, yet possibly ideal for other types of life forms. With advanced space telescopes like the James Webb, we can now explore the atmospheres of distant planets in greater detail than ever before. Thanks to the recent incredible discoveries by the JWST, it seems clear that many more astonishing findings are on the horizon. In fact, some scientists believe that there could be planets in the universe with even more favorable conditions for life than Earth. These planets are known as superhabitable worlds. Imagine a planet that is larger, safer, and more hospitable than Earth, free from the challenges we currently face. Though still a theoretical concept, superhabitable worlds would likely be older, bigger, warmer, and perhaps even more humid than Earth. Many researchers speculate that these planets might orbit stars much older than our Sun, with significantly longer lifespans. For example, while our Sun has an expected lifespan of about 10 billion years, it took nearly 4 billion years for life to develop on Earth. Some stars, however, can last much longer than 10 billion years, allowing for a more prolonged and intricate evolutionary process on their orbiting planets. But how can we locate these ideal planets? According to many experts, the best approach is to search for planets orbiting orange stars that are cooler and less bright than our Sun. Such stars would need lifespans between 20 and 70 billion years. It is believed that life on planets around these stars could evolve fully, reaching a point where the planet's geological features and life forms are at their most developed. These superhabitable worlds would likely offer many advantages over Earth, such as more landmass, heat sources that last longer, better protection from radiation, and ideal gravitational conditions. For a planet to be truly superhabitable, it should also have an average surface temperature about 500 degrees Celsius warmer or cooler than Earth's, promoting greater biodiversity. Although no such planet has been found yet, scientists remain optimistic. The scientific community at least has a clearer idea of what they are looking for and where to search. Still, there are skeptics who argue that no planet could be better suited for human life than Earth. If such a planet existed, they claim, it would have already been discovered. However, it's important to note that the technology we have now wasn't available in the past, which might explain why we haven't found one yet. Perhaps with future advancements, our telescopes will one day reveal the perfect planet for humanity. For now, the search for a new home continues. Thanks for watching this episode. Be sure to click the video on your screen for more fascinating insights into space. Close to the blazing sun, a tiny planet holds monumental secrets. Mercury, the smallest and hottest planet, tricked us for a long time, but today space probes have uncovered strange and unexpected surprises. They even suggest the possibility of diamonds existing on the hottest planet.
Scientists have found that a thick layer of diamonds may exist hundreds of miles beneath Mercury's surface.
And that's only scratching the surface. Mercury's internal structure is unusual, too large, too peculiar. What makes it so different from the other planets? And what other hidden secrets might Mercury still be keeping? Mercury, the smallest planet in our solar system, has captivated the interest of astronomers and space enthusiasts for years. Its enigmatic surface, veiled for centuries, only began to unveil its mysteries with the advancement of space exploration technology. The quest to understand Mercury's bizarre landscape started with NASA's Mariner 10 mission in 1973 and continued with the Messenger probe, which launched in 2004. Mariner 10, the first spacecraft to fly by Mercury, provided us with our initial close-up look at this elusive planet. As it passed by, it captured images revealing a landscape covered in craters and unusual ridges, similar to our moon. This mission showed that Mercury had a rough, cratered exterior, along with an unexpectedly strong magnetic field and a much larger core than scientists anticipated. These discoveries reshaped previous assumptions about Mercury's composition. The Messenger mission, formerly known as Mercury Surface, Space Environment, Geochemistry, and Ranging, was launched 31 years after Mariner 10. It significantly expanded our knowledge of Mercury. Unlike Mariner 10, Messenger was designed to enter Mercury's orbit, allowing for an in-depth study of the planet. Over the course of its mission, Messenger captured an astonishing 200,000 images, revealing never-before-seen regions of Mercury. One of the most fascinating discoveries made by Messenger was the detection of unusually high levels of calcium and magnesium on Mercury's darker side. This sparked questions about what processes could create such unusual concentrations. Additionally, the mission revealed that Mercury's magnetic field was notably stronger in its northern regions, a surprising difference from other planets. These findings led scientists to understand that Mercury's interior structure and formation history were vastly different from what they had previously assumed. On planets like Earth, magnetic fields are created by the movement of liquid iron within the core. However, Mercury's internal makeup produces a unique magnetic behavior. What makes Mercury's surface particularly remarkable, though, isn't just the craters and ridges, but also the extreme surface conditions. By day, temperatures on Mercury can reach a scorching 430 degrees Celsius, 806 degrees Fahrenheit, hot enough to melt lead. At night, however, these temperatures drop to an icy minus 180 degrees Celsius, minus 292 degrees Fahrenheit. These wild temperature swings are due to Mercury's very thin exosphere, which provides little insulation or heat retention. Even in these harsh conditions, researchers have found surprising features on Mercury's surface. In 2012, Messenger data revealed signs of volcanic activity, including pyroclastic deposits from explosive eruptions. This discovery overturned the long-standing belief that Mercury was geologically inactive. Even more remarkable, in 2020, scientists announced the discovery of water ice in Mercury's polar craters. These permanently shadowed regions are so cold that they can preserve water ice, even though Mercury is extremely close to the Sun. This discovery has led to new speculation about the possibility of simple life forms on Mercury. Could extremophiles, like those that exist in extreme conditions on Earth, be living in these icy pockets? The most recent Mercury mission, Bepi Colombo, was launched in 2018 as a collaborative project between the European Space Agency and the Japan Aerospace Exploration Agency. The spacecraft is expected to arrive at Mercury in 2025. This mission promises to deliver even more detailed data about Mercury's surface, including its chemical composition and geological evolution. From its unexpectedly strong magnetic field to the existence of water ice, Mercury continues to astonish scientists. Now, if you thought Mercury's secrets were done, think again. What you're about to learn will completely flip your understanding of time on this planet. A year shorter than a day. When we typically think of planets, we imagine them spinning once on their axis per day and orbiting the Sun once per year. However, Mercury defies this usual pattern in a very intriguing way. On this small sun-baked planet, a single year is actually shorter than a day. Let's explore this peculiar fact. Mercury completes an orbit around the Sun in just 88 Earth days, making its year far shorter than our own. But here's where it gets even more fascinating. One full rotation of Mercury on its axis, a single day, takes an astounding 176 Earth days. This means that on Mercury, a year is only half the length of a day. This odd scenario leads to some truly strange phenomena. If you were standing on Mercury's surface, you would witness the Sun rise and grow larger in the sky as it slowly moved. At one point, the Sun would appear to stop, move backward for a while, and then resume its usual path. This bizarre movement happens because Mercury's rotation cannot keep pace with its quick orbit. But what causes Mercury's sluggish rotation? Scientists believe the answer lies in a process called tidal locking. Over billions of years, the Sun's gravitational pull has gradually slowed Mercury's spin. Unlike our Moon, which is entirely tidally locked to Earth, Mercury exhibits a 3-to-2 spin-orbit resonance. This means it rotates 3 times for every 2 orbits around the Sun. The extreme nature of Mercury's day-night cycle has intense consequences on its surface. The side facing the Sun is scorched by extreme heat for months, while the night side is left in freezing darkness for an equally long time. These extremes contribute to some of the most dramatic temperature swings in the solar system. As for Mercury's atmosphere, or lack thereof, it is worth noting that the planet's extremely thin atmosphere is called an exosphere. This fragile layer is constantly being lost to space and replenished by various processes such as the solar wind, radioactive decay, and impacts from micrometeorites. Surprising new discoveries have recently been made about Mercury's exosphere. In 2020, researchers analyzing data from the Messenger spacecraft revealed that Mercury's exosphere contains more water vapor than previously thought. This water vapor likely forms when hydrogen from the solar wind combines with oxygen in Mercury's rocky surface. Mercury's short year and long day also have fascinating effects on its magnetic field. Despite its small size and slow rotation, Mercury has a global magnetic field, a finding that surprised scientists. New research indicates that Mercury's magnetic field may be created by a unique dynamo effect in its liquid metal core, influenced by its peculiar orbital and rotational dynamics. This magnetic field, although much weaker than Earth's, plays a vital role in shielding Mercury's surface from the relentless solar wind. Without it, the solar wind would erode Mercury's thin exosphere even faster. Additionally, Mercury's rapid orbit and sluggish spin create opportunities for intriguing observations. Specific points on the planet, known as hot poles, experience the most intense heat because the Sun appears to linger in the sky there. On the other hand, there are regions near Mercury's poles that never see sunlight. These permanently shadowed areas are where scientists have discovered signs of water ice. How can water ice exist on a planet so close to the Sun? The answer lies in Mercury's orbit and rotation. The permanently shadowed craters at its poles remain in constant darkness, keeping temperatures cold enough to preserve the ice even while nearby areas are baked by the Sun's heat. This finding leads scientists to ponder whether other volatile substances, perhaps even organic compounds, might also be preserved in these frozen traps. Mercury's short year and lengthy day also impact how we study the planet. Its fast orbit makes it difficult for spacecraft to reach Mercury, requiring complex maneuvers and multiple flybys of Venus and Mercury itself to slow down enough for orbital insertion. The Bepi-Colombo mission, currently en route to Mercury, will rely on these gravitational assists to adjust its speed and trajectory. Although launched in 2018, the spacecraft will not enter Mercury's orbit until 2025, after completing 9 planetary flybys. Once in orbit, Bepi-Colombo will face another hurdle due to Mercury's unusual day-night cycle. The spacecraft must balance exposure to Mercury's intense heat during the day and maintain power through the long, freezing nights. This delicate operation will be critical for the mission's success, demonstrating the extreme conditions created by Mercury's rotation and orbit. Recent simulations have shed light on how Mercury ended up with such a peculiar rotation rate. These studies suggest that Mercury once rotated more quickly, but its spin was gradually slowed down by the Sun's gravitational forces and impacts from large comets or asteroids. Understanding Mercury's slow spin helps scientists piece together not only its history, but also the evolution of other planets in our solar system. As researchers continue to explore Mercury, new mysteries emerge. How does Mercury's core stay partly liquid despite the intense cold during its long nights? What role does Mercury's strange orbit play in its geological processes? These questions remind us that even within our own solar system, many puzzles remain unsolved. Mercury's unique characteristics push us to reconsider how planets form and evolve, encouraging new ideas and theories. Just when you think you've wrapped your head around Mercury's bizarre day, the planet throws another curveball. Its secrets are far from over. A small planet with too many intense secrets. Mercury, the tiniest planet in our solar system, manages to hold an astonishing number of mysteries despite its small size. Scientists continue to be intrigued by Mercury as its distinctive features and unexpected discoveries defy initial expectations. One of the most captivating mysteries of Mercury lies in its unusually large core. Dr. Nancy Chabot, a planetary scientist at Johns Hopkins Applied Physics Laboratory, conducted a study revealing that Mercury's core accounts for about 85% of its total volume. This is significantly larger compared to Earth's core, which only takes up about 15% of its volume. But what caused Mercury to have such an enormous core? One theory suggests that Mercury might have once been a much larger planet, but a colossal collision early in the history of the solar system caused it to lose most of its outer layers. This hit-and-run theory was proposed by Dr. Eric Asfog from the University of Arizona, who believes that a planetesimal struck Mercury, stripping away much of its mantle and crust, leaving behind the iron-rich core that we observe today. Mercury's magnetic field presents another puzzling mystery. Unlike Venus and Mars, which lack global magnetic fields, Mercury generates a magnetic field that is about 1% as strong as Earth's. This unexpected discovery, made by NASA's MESSENGER mission, surprised scientists because they didn't expect a planet as small and slowly rotating as Mercury to maintain a magnetic dynamo. Further intrigue was added by Dr. Katherine Johnson, a planetary scientist from the University of British Columbia. Her team discovered that Mercury's magnetic field is offset from the planet's center by roughly 20% of its radius. This offset could result from variations in the thickness of Mercury's crust, which influences how heat is distributed from the planet's interior. The surprises don't end there. In 2020, scientists announced the detection of volatile elements on Mercury's surface, including sulfur, potassium, and sodium. These elements typically evaporate quickly at high temperatures, so their presence on a planet so close to the Sun was unexpected. Dr. Patrick Poplawski from Johns Hopkins Applied Physics Laboratory proposed that comets or asteroids could have delivered these volatile elements to Mercury after it formed. One of the most remarkable recent discoveries on Mercury is the presence of water ice in permanently shadowed craters near its poles. Dr. Nancy Chabot, who was also involved in this research, found that despite Mercury's proximity to the Sun, these craters remain cold enough to preserve ice due to their lack of direct sunlight. Adding to the excitement, scientists have found evidence of organic compounds in the same craters where water ice was discovered. These dark deposits could be complex carbon-based molecules, possibly similar to the ones that may have contributed to the origin of life on Earth. Despite the harsh environment, could Mercury hold clues to the beginnings of life in our solar system? Another significant revelation about Mercury is its unexpected geological activity. For a long time, Mercury was thought to be a geologically dead world, but messenger data indicated recent volcanic activity. Dr. David Rothery from the Open University in the UK found bright spots on Mercury's surface that are believed to be volcanic vents. These features, called hollows, suggest that Mercury could still be geologically active today. One of the most perplexing characteristics of Mercury is its chaotic terrain, an area of disrupted hills and valleys near the South Pole. First observed by the Mariner 10 mission in the 1970s, this region spans an area roughly the size of Texas. Dr. Thomas Waters from the Smithsonian Institution proposed that this terrain might have been shaped by massive earthquakes triggered by the sun's tidal forces as Mercury's orbit shifted. Additionally, recent investigations have uncovered intriguing information about Mercury's structure. Dr. Amir Khan from the University of Zurich utilized data from the Messenger mission to study Mercury's interior. His team discovered that Mercury's core is composed of a liquid outer layer and a solid inner core, similar to Earth's. However, Mercury's inner core is proportionally much larger than Earth's, which could provide insights into some of Mercury's unusual magnetic properties. The fascinating discoveries on Mercury continue to challenge our understanding of how planets form and evolve. Even within our own solar system, there are many unexplained mysteries. Hold on, because Mercury's surface may have shocked you, but what's hidden below will leave you questioning everything. Mercury's hidden depths. Recent investigations and ongoing missions are revealing that Mercury's underground regions hold secrets that are just as fascinating as its surface features. One of the most intriguing aspects of Mercury's subsurface is its core structure. Unlike Earth, which has a solid inner core encased in a liquid outer core, Mercury's core is primarily liquid with a solid inner portion. This unique composition was confirmed by NASA's Messenger mission, which utilized slight variations in Mercury's gravitational field to map its internal structure. The solid inner core of Mercury is estimated to be approximately 1,260 miles or 2,000 kilometers across, accounting for nearly half of the planet's core. In comparison, Earth's inner core only makes up around 20% of its core volume. This difference in proportion plays a critical role in the generation of Mercury's magnetic field, which, although much weaker than Earth's, is surprisingly strong given Mercury's small size. Beneath the crust of Mercury lies a mantle that is thinner than previously thought. Studies now suggest that this mantle might be just 260 miles or 420 kilometers thick, while Earth's mantle measures about 1,800 miles or 2,900 kilometers. This relatively thin mantle has significant implications for Mercury's geological activity and the way heat is distributed through the planet. One of the most thrilling discoveries about Mercury's subsurface was made in 2012, when Messenger detected evidence of ancient volcanic activity. The spacecraft identified shallow depressions, known as hollows, that appeared to form when volatile elements sublimated from the planet's surface. These hollows indicate that Mercury's interior once contained more volatile elements than scientists had previously assumed. In 2020, researchers using Messenger data made another groundbreaking discovery beneath Mercury's surface. They uncovered evidence of a large underground reservoir of magma from Mercury's distant past. This ancient magma ocean likely played an essential role in shaping both the surface and the internal structure of the planet. This ancient magma ocean may explain some of Mercury's unusual surface features, such as the vast, smooth plains covering much of its northern hemisphere. These plains, referred to as the northern volcanic plains, are thought to have resulted from massive lava flows early in Mercury's history. However, the most shocking discovery about Mercury's subsurface came in 2022. Researchers analyzing Messenger data found traces of nitrogen trapped below Mercury's surface. This nitrogen may be a remnant of an ancient atmosphere that was driven underground by the intense heat and solar radiation that bombard the planet. The presence of nitrogen in Mercury's subsurface raises intriguing questions about its past. Could the planet once have had a more substantial atmosphere? If so, what might this tell us about its early climate and even the possibility of habitability? Another interesting feature of Mercury's hidden depths is the presence of water ice in craters near its poles, which remain in permanent shadow. Although this ice is technically on the surface, it is hidden from direct view, protected by the extremely cold conditions within these shadowed craters. Some studies suggest that this ice might be relatively fresh, possibly deposited by comets or asteroids within the last tens of millions of years. In addition to water ice, these polar craters are also home to dark deposits that scientists believe might be organic compounds. These compounds, more volatile than water ice, could be remnants of comets or asteroids that impacted Mercury. The preservation of these organic materials within Mercury's subsurface offers a unique opportunity to explore the distribution of organic compounds within the inner solar system. Mercury's subsurface also offers insights into its tectonic history. While Earth has plate tectonics, Mercury does not, but there is evidence of significant contraction as the planet cooled over time. This contraction led to numerous thrust faults, where one section of crust is pushed up over another. These faults, which can be several kilometers high, give us a window into Mercury's subsurface composition and geological past. Recent studies of these thrust faults have revealed something unexpected. Mercury might still be tectonically active. In 2019, researchers found small landforms known as grabens in association with some of Mercury's larger faults. These grabens, which are small valleys formed as the crust stretches, appear geologically young, suggesting that the planet's crust is still moving and shifting. Mercury's magnetic field is another mysterious aspect of its subsurface. While Earth's magnetic field is generated by the movement of molten iron in its outer core, Mercury's magnetic field may be produced by a different process. Some scientists propose that it is generated by a dynamo effect within a thin layer of liquid metal encircling a solid inner core. Another intriguing element of Mercury's hidden depths is the possibility of subsurface faults and fractures that might create pathways for heat and potentially even fluids to move through the planet's crust. Even though Mercury's surface is dry today, some researchers speculate that there could be pockets of liquid water deep beneath the surface, kept liquid by residual heat from the planet's core. The idea of subsurface water on Mercury might sound improbable, but similar phenomena have been observed on other seemingly inhospitable worlds within our solar system. For example, Jupiter's moon Europa and Saturn's moon Enceladus both have subsurface oceans beneath their icy surfaces. Although Mercury's environment is quite different, the potential for subsurface water cannot be completely dismissed. As we continue to investigate Mercury's hidden depths, new questions emerge. How has the planet's internal structure evolved over time? Could there be other volatile elements or compounds lurking beneath the surface? And perhaps most fascinating, what might Mercury's subsurface reveal about the early history of our solar system and the processes that shape the inner planets? These questions underscore the importance of ongoing exploration of Mercury. Each new discovery about its hidden depths not only expands our understanding of this extraordinary planet, but also provides vital clues about planetary formation and evolution throughout the solar system. Looking ahead to future missions and discoveries, one thing remains clear. Despite its small size and proximity to the Sun, Mercury still has many mysteries to uncover. Its hidden depths contain valuable insights into its history and possibly the history of the entire solar system. What a fascinating journey, right? Share your thoughts about what other surprises might be lying in wait on Mercury. Could we find rare minerals or even clues to extraterrestrial life? If you enjoyed this video, don't forget to hit that like button and subscribe to the channel for more updates. Thanks for watching and see you in the next one.
Well, that's the problem. The James Webb Space Telescope is upsetting the apple cart. All of a sudden, we realize that we may have to rewrite all the textbooks about the beginning of the universe.
Could an alien civilization really exist right next door to us? Based on the most recent findings from the James Webb Space Telescope, it might actually be a possibility. Yes, you heard that correctly. Some unusual lights have been detected coming from the vicinity of Proxima B, the exoplanet closest to Earth. What if this signal, known as BLC1, is more than just a random occurrence? Could it be the long-sought evidence of extraterrestrial life? Well, scientists are already preparing their tools to investigate this exciting lead. So are you eager to learn more about this astonishing discovery? But first, let's dive into what we've learned about this fascinating planet. Proxima B holds some mysteries of its own, and recent discoveries have only added to the excitement. Proxima B's mysterious nightlights. Proxima B has captured the attention of scientists since its discovery in 2016, and with good reason. Situated just 4.24 light-years away, it orbits within the habitable zone of Proxima Centauri, which suggests the potential presence of liquid water, a key ingredient for life. Naturally, this stirred excitement about the possibility of finding life there. However, there's a complication. Proxima B's star is a red dwarf, and red dwarfs are notorious for their unpredictability. These stars emit intense solar flares, which could strip away a planet's atmosphere, transforming what could be a life-supporting environment into a barren wasteland. Still, astronomers have been drawn to investigate further, curious to see if Proxima B might hold some surprises. And it's certainly delivered with intriguing findings from the James Webb Space Telescope. This powerful observatory, designed to unveil the universe in unprecedented detail, is equipped with advanced infrared sensors that can detect even faint signals from distant celestial objects. It is capable of revealing conditions on exoplanets, such as their atmospheres and surfaces, and potentially signs of alien life. Recently, JWST focused its gaze on Proxima B to search for markers of life like methane, oxygen, or water vapor. Instead, it detected something unexpected, a dim, steady glow coming from the planet's night side. This wasn't the work of auroras or any natural phenomenon. Instead, it bore a striking resemblance to the kind of artificial light we see on Earth at night when viewed from space, a city-like glow. This discovery raises an array of tantalizing questions. If these lights are the result of an alien civilization, just how advanced are they? The distribution and intensity of the lights could provide some clues. Are we looking at a sprawling metropolis or perhaps smaller, interconnected towns? And then there's the bigger question, how are they powering those lights? Are they using methods similar to ours, like electricity? Or have they harnessed some revolutionary, ultra-efficient energy source we haven't even imagined yet? This discovery also challenges our assumptions about where life can thrive. Proxima B circles a red dwarf star, long considered too hostile for life due to its violent solar flares. Yet if intelligent life, potentially capable of building cities, can exist around such stars, we may need to rethink our ideas about where life can flourish. Since red dwarfs are the most common stars in the galaxy, the implications are staggering. How many other worlds previously dismissed might also host life? This could just be the beginning of a much larger revelation. This discovery could radically alter the trajectory of space exploration. Proxima B is incredibly close in cosmic terms, just 4.24 light-years away. While that may seem far by human standards, it's practically next door in astronomical terms. There's already talk about sending probes or even human missions to nearby star systems, thanks to advancements in propulsion technology. Now, with the possibility of alien city lights on Proxima B, that ambition might accelerate. Imagine a mission dedicated solely to investigating a nearby extraterrestrial civilization. This also changes the way we've traditionally searched for extraterrestrial life. SETI has historically focused on detecting radio signals from other worlds, but now we're realizing we should also be looking for signs of alien technology, such as artificial lighting or massive structures. This could spark a new era for SETI, with researchers scanning the universe for these kinds of technological signatures from distant worlds. Beyond the scientific community, this discovery has ignited the imaginations of people everywhere. The thought of an alien civilization so close, with lights we can actually observe, is exhilarating. People from all over the world are now following updates from JWST and other observatories, eagerly awaiting what might come next. So what do these mysterious lights tell us about the kind of civilization that might exist on Proxima B? The possibilities are endless and could change everything we know about intelligent life. What Proxima B reveals about advanced civilizations? The idea that we might not be alone in the universe brings up some major challenges to how we view ourselves as humans. For a long time, we've considered ourselves the peak of intelligence, believing we might be the only advanced beings. But if the lights on Proxima B do belong to a civilization, then we could be just one of many intelligent species in the galaxy. This realization would force us to reconsider our place in the cosmos and think about what responsibilities we have, both to Earth and to any technology we share with other intelligent life. This discovery could also transform how nations work together in space. Sending a mission to Proxima B or even establishing contact isn't something any single country can handle alone. It's a task that's just too big. We've already seen international cooperation succeed in projects like the International Space Station, and finding an advanced alien society might inspire even more global teamwork. This could unite countries in a shared pursuit of exploring the universe and expanding our understanding. A major question is how this alien civilization has managed to survive in such a hostile environment. Proxima Centauri, the star it orbits, frequently emits powerful solar flares, which could destroy life or strip the planet of its atmosphere. If the lights we see on Proxima B are artificial, it implies the beings there have developed advanced technologies, perhaps to regulate their atmosphere or build shields to block harmful radiation. They might have even adapted biologically or through technological advancements to survive these extreme conditions, which would open our eyes to new possibilities for life in the universe. Then there's the mystery of the energy behind those lights. Could they be tapping into a power source so advanced that we can't even imagine it yet? If they're not using electricity like we do, maybe they've mastered technologies like antimatter, zero-point energy, or even harnessing energy directly from their star. The way these lights are distributed across the planet could offer clues to their technological progress. And if they have accessed energy resources far beyond anything we've conceived, it could revolutionize how we think about power and energy on Earth. The arrangement of these lights could also reveal how their civilization is structured, technologically and socially. Imagine their cities are built upwards, with immense towers emitting light into the sky, or perhaps they have harmonized their technology with nature, creating glowing forests or seas. How they have built their world might tell us a lot about their values. Are they explorers eager to share their knowledge and culture, or are they a secluded society, uninterested in interacting with others? Considering their apparent technological capabilities, they may have even figured out how to travel between star systems. If they've been exploring other planets, they might already know about other intelligent civilizations. This could change everything, not just in terms of our search for extraterrestrial life, but also in how we understand the universe as a network of civilizations sharing knowledge and resources across vast distances. One fascinating aspect of this discovery is how recent it could be. Since Proxima B is only 4.24 light-years away, the light we're seeing left the planet just over 4 years ago. This means a civilization might be living in real time, developing socially and technologically at the same pace as us. Alternatively, they could be much older, possibly having reached a technological plateau, or worse, maybe their civilization has already fallen apart, and the lights we see are the final traces of what was once a thriving society. What's mind-blowing is just how close they are in cosmic terms. Theoretically, we could communicate with them in just over 4 years, an instant compared to the centuries or millennia it would take to reach civilizations in more distant systems. This opens up the real possibility of interstellar communication within our lifetimes, something that until now seemed like pure science fiction. If we sent a signal to Proxima B, we could receive a reply in just 9 years, potentially leading to humanity's first two-way conversation with an alien civilization. Of course, we'd have to figure out how to communicate, what language or medium to use, and make sure we both understand each other. But the relatively short time between signals means we could have real-time exchanges, sharing scientific knowledge, ideas, and maybe even cultural insights. What's even more thrilling is the idea that these city lights are just the beginning. There could be all kinds of other signals coming from Proxima B that we haven't detected yet. Perhaps they're using forms of communication we can't even pick up on, like radio signals, energy fields, neutrino emissions, or gravitational waves from massive engineering projects. As our technology improves, we could learn more about how this alien society operates and what they've achieved, offering us glimpses of what humanity might be capable of in the future. And then there's the question of who or what is behind these lights. If an advanced civilization exists on Proxima B, the beings living there might be radically different from us. They've evolved under completely different conditions, orbiting a red dwarf star that constantly bombards them with radiation. Maybe they've developed special biological adaptations to survive, or perhaps they live in a world where technology and biology have merged, creating a post-biological society of cyborg-like beings. These possibilities would force us to rethink everything we know about life and intelligence. Of course, with such an exciting discovery comes some tough questions. How do we handle the responsibility of making contact with an alien civilization? Let's explore the ethical challenges that lie ahead, the ethical dilemmas of contacting Proxima B. Learning from a civilization that has confronted the same kinds of challenges we face but might have found solutions we haven't yet discovered could be transformative. Their ways of governing, their art, their philosophies, and even their science would be influenced by an entirely different environment. And through the exchange of ideas, we could witness a surge in creativity and thought. But this also brings significant ethical responsibilities. How do we approach contact with them in a way that shows respect? Do we send out probes or spacecraft to observe them directly? Or could that come across as invasive? Should we try to communicate, knowing that doing so might expose them to our culture, technology, or even diseases that could have devastating effects? These ethical concerns, which have been long debated within the field of astrobiology, have now become more pressing than ever. If we are truly on the brink of discovering an alien civilization, the stakes have never been higher. What we choose to do next could have a profound impact on the future of humanity and our role in the cosmos. The history of first contact between human civilizations, often marked by violence, conflict, and exploitation, serves as a stark reminder of the need for extreme caution as we approach the possibility of an encounter with extraterrestrial life. We must be careful to avoid repeating such mistakes on a universal scale. The revelation of city lights on Proxima B forces us to reassess our place in the universe. If we are not alone, and intelligent life exists just a few light years away, then we could be part of a far greater, interconnected cosmic community than we ever imagined. But let's not get ahead of ourselves. This discovery isn't just a scientific milestone. It reaches deeply into the realms of ethics, philosophy, and the very future of humanity. It could drastically change the way we understand life in the universe, and may even redirect the course of our civilization. One of the most immediate and profound changes could be the way we come together as a species. For most of history, humanity has been divided by borders, ideologies, and cultural differences. But if we learn that intelligent life exists beyond Earth, this realization could spark a sense of global unity. Much like the Apollo moon landings in the 1960s united humanity in a shared sense of wonder, knowing that we have alien neighbors might inspire collaboration that transcends political boundaries, driving us toward a shared mission to explore and learn. Ultimately, the discovery of city lights on Proxima B could ignite not just curiosity, but a unified desire to better understand our place in the cosmos, together. The technological ramifications of finding an alien civilization on Proxima B are nothing short of staggering. If they have the capability to light up their entire planet, then they might be using energy sources that make our current technology seem primitive by comparison. This could trigger a new wave of research on Earth into energy production, especially as we face the urgent challenge of finding sustainable solutions to mitigate climate change. It's entirely possible that their civilization has already solved the energy crises we currently grapple with, giving us a glimpse of what humanity could achieve if we take bold steps towards a future like theirs. Consider the concept of a Dyson sphere, an enormous structure designed to harness energy directly from a star. At present, this idea exists only in the realm of theoretical physics. But if the aliens are utilizing something similar to power their cities, it would be proof that such megastructures are not just a work of science fiction. This discovery could completely revolutionize our approach to energy sustainability, perhaps leading to breakthroughs that help save our planet. Beyond energy, their technological advances could trigger innovations in artificial intelligence, robotics, and even medicine. If they've found ways to combine organic and synthetic technologies, we might learn how to enhance human abilities through cybernetic upgrades. Imagine better health, sharper cognitive abilities, or even extended lifespans. The mere concept of reverse engineering alien technology could spark a frenzy within the scientific community, pushing the boundaries of what we believe is possible and leading to developments that could reshape the world. However, great discoveries come with significant ethical dilemmas. If we begin to interact with this alien civilization and start to learn from them, how should we manage the transfer of their advanced technology? Introducing something so powerful into our society could lead to unforeseen consequences. Geopolitical tensions over who controls access to these alien resources or advanced tech might arise, much like how nuclear weapons reshaped global power in the 20th century. We would need to proceed with caution and weigh the risks before embarking on any kind of technological exchange. On the other hand, the cultural impact of confirming intelligent life on Proxima B would be just as monumental. Our collective identity as humans would undergo a radical transformation as we come to terms with the fact that we are not alone in the universe. Questions surrounding the nature of life, intelligence, and our place in the cosmos would emerge with greater urgency. For centuries, these topics have been the subject of debate in both scientific and religious circles. And now the existence of another intelligent species would force us to reevaluate long-standing beliefs. Religious perspectives, in particular, could face significant challenges. Many faith traditions assert that humanity is unique, created by a divine being with a special role in the universe. How would those beliefs shift when confronted with the undeniable presence of other intelligent species? This revelation could spark intense theological debates about the nature of creation and humanity's place in the cosmic order. Some religious leaders may seek to reinterpret sacred texts in light of these new discoveries, while others may see this as evidence of a grander, interconnected cosmic plan offering new spiritual interpretations. In essence, the discovery of city lights on Proxima B could mark the beginning of a new era for humanity, filled with technological wonders and deep philosophical shifts. The challenge will lie in navigating this new terrain thoughtfully and responsibly, ensuring that we learn and grow from this encounter without repeating the errors of our past. From a philosophical standpoint, the discovery of intelligent life beyond Earth could truly disrupt our belief that humanity is the crowning achievement of evolution. For generations, we've carried ourselves as if we were the apex of intelligence, the most creative and technologically advanced beings in the universe. But if we come across another civilization, especially one that surpasses us, it will force us to reevaluate our place in the cosmic hierarchy. One pressing question is whether life on Proxima B evolved in a way similar to life on Earth. Are the same biological and evolutionary principles at work? Or has life on Proxima B taken a completely different path that would leave us bewildered? If the beings on Proxima B are indeed intelligent, how did they build their society? Did they go through similar technological and social developments as we did? Or did they follow a completely different trajectory? These are not merely academic inquiries, but profound philosophical challenges that demand answers. And the answers won't come easily. Governments, scientists, and ethicists alike will need to engage in deep, collaborative discussions. This discovery could also send space law and governance into chaos. Right now, we have treaties like the Outer Space Treaty, designed to prevent the militarization of space and to keep celestial resources out of any one nation's hands. But these agreements were made in a time when the idea of meeting extraterrestrial life was seen as nearly impossible. With the potential discovery of alien life on Proxima B, it may be time to rethink those treaties. How do we share cosmic resources? What guidelines should we follow in making first contact? These questions could spark a new era in international space governance. And let's not overlook how this revelation could revolutionize education. Imagine schools packed with students eager to study astronomy, physics, biology, and engineering, all inspired by the possibility of exploring space and discovering alien life. Public enthusiasm for science would likely soar, with museums and media outlets racing to explain the significance of the lights on Proxima B. Thanks for watching the video. Do you believe those lights on Proxima B are proof of intelligent life? Share your thoughts in the comments below. If you enjoyed this video, don't forget to give us a thumbs up and subscribe to the channel for more thrilling updates like this. Imagine waking up to a headline that reads, NASA discovers Earth 2.0. Sounds incredible, right? A planet just like ours with oceans, breathable air, and maybe even life. Well, as exciting as that sounds, the truth is far from it. Despite the countless planets we've discovered, we haven't found a single one that we can truly call habitable. Today, we're going to cut through the hype and look at why none of the so-called Earth-like exoplanets are actually capable of sustaining life as we know it. If you're ready to separate fact from fiction, let's dive in. We will be going planet by planet to explain why each potentially habitable exoplanet is probably inhospitable, and afterward, we will go over some planets that actually have a better chance of being habitable. Let's start with the well-known Kepler-22b. Kepler-22b is in its star's habitable zone, meaning temperatures are right for liquid water. However, beyond that, it has no similarities to Earth and should have been removed from the list of potentially habitable exoplanets long ago. For one, we don't accurately know its mass. We only know it's less than 9 times the mass of Earth, but nothing more. We do know its radius, which is 2.3 times wider than Earth's. Rocky planets don't usually get that large, and with Kepler-22b's likely mass, there's really only one reasonable conclusion. Kepler-22b isn't a rocky planet. This means it probably doesn't even have a solid surface, and more closely resembles Neptune than Earth. There is a possibility that Kepler-22b could be a planet entirely covered in hundreds of miles of water, which could explain its low density. However, just because water might be present doesn't mean the planet is habitable. Oceans this deep are unlikely to be suitable environments for life. From what we know, life seems to require volcanic activity to get started, either through hydrothermal vents in the deep ocean or hot springs on land. Achieving these conditions is difficult when all the volcanoes are submerged beneath an ocean, with such high pressure that the bottom layers turn solid. This extreme pressure makes it nearly impossible for the necessary chemical interactions to occur, which are crucial for the emergence of life. So whatever Kepler-22b is, it's probably more like a smaller version of Neptune or an ocean planet with water too deep to support life. It's safe to conclude that despite having the right temperatures for life, Kepler-22b most likely doesn't have anything else that would make it habitable. This is crucial for understanding the rest of this video. Just because an exoplanet is in the habitable zone of its star doesn't mean it's actually habitable. The habitable zone only indicates that a planet within it could have the right temperatures for liquid water on its surface. It says nothing about the amount of water, its atmosphere, whether it has enough atmospheric pressure to support liquid water, its size, or any of the other key factors needed to make a planet truly habitable. From what we know so far, habitable planets are rare, extremely rare. Anyway, the next exoplanet on this list is Kepler-186f. At first glance, Kepler-186f looks a lot more promising than Kepler-22b. For one thing, it has a mass that's pretty close to Earth's, at around 1.5 times Earth's mass, which means it's most likely a solid planet with a rocky surface. Out of all the planets I'm going to discuss today, Kepler-186f is one of the few with the best potential for habitability. However, it does have a significant drawback. Its equilibrium temperature sits at around 120 degree, 85 degree, which makes it colder than the average day on Mars. In fact, its temperature is roughly between what you'd expect on Mars and Jupiter. To be fair, we don't actually know Kepler-186f's real temperature. The estimate we have assumes it has no atmosphere. If it does have one, a greenhouse effect could warm it up. However, that doesn't change the fact that this planet would still be extremely cold, even with an Earth-like atmosphere. If you manage to give it an atmosphere thick enough to make temperatures more habitable, it would be very easy to go too far and end up with a Venus-like atmosphere. So Kepler-186f is probably either too cold to support life in a very delicate and unlikely balance, or it could be a hellish Venus-like world. It's caught between two bad extremes, and we just don't know which one is the case. There is still a small chance that Kepler-186f could be habitable, but we wouldn't get our hopes up. You might have heard that Kepler-186f could have red plants if it were habitable, and that's likely true. However, this planet highlights a bigger issue in exoplanet science. people tend to focus almost exclusively on planets that might be habitable. Whenever Kepler 186 comes up, no one ever seems to mention Kepler 186b, C, D, and E, the other 4 planets in the system. These planets, all between 1 to 2.5 Earth masses, orbit much closer to the star than Kepler 186f. They are 4 additional worlds, each with the potential to be just as interesting as places like Mars, Venus, Titan, or Mercury, yet they hardly get any attention. Planets don't need to be habitable to be fascinating, but by constantly zeroing in on possible habitable worlds like Kepler 186f, we end up overlooking the thousands of other equally intriguing planets out there, waiting to be explored. But it only gets worse from here. Compared to Kepler 186f, Proxima B is, in our opinion, the least likely to be habitable of any planet on this list. In fact, it's not just uninhabitable, but so extremely uninhabitable that Mars and Venus look like paradises in comparison. And we are not exaggerating. The idea that Proxima B could even be considered potentially habitable is baffling because so much is going wrong with it that habitability seems impossible. Of course, we won't know for sure until we learn more about its environment, but with the data we have so far, Proxima B appears as good as dead. Everything that could possibly go wrong for Proxima B has, from its star's behavior to its distance from that star and the existence of Proxima Ca, a second planet in the same system. Proxima B seems to have everything working against it. Here's a quick list of what likely makes Proxima B an irradiated wasteland that would make Mercury jealous. First, it orbits a red dwarf prone to flares. Second, these flares likely stripped away any atmosphere and oceans, assuming it ever had them. Third, red dwarfs, especially when young, often eject volatiles like water, making it unlikely that Proxima B even formed with water in the first place. 4. Proxima B is likely tidally locked to its star, meaning one side of the planet always faces the star, while the other remains in perpetual darkness. This creates extreme temperature differences between the two sides, which would make it incredibly difficult for any form of life to survive. 5. Proxima C exists, and there's some evidence suggesting an asteroid belt between the 2 planets. If this belt is indeed real, Proxima B would be in a prime location to have asteroids flung toward it from time to time. Over the planet's long history, these asteroid impacts may have been frequent and severe enough to completely sterilize any chance for life to develop. And 6, temperatures on Proxima B can spike drastically due to flares from its star, Proxima Centauri, which regularly bombards the planet with intense radiation. It's really bad. With all of this working against it, it's difficult to imagine that Proxima B could be habitable. Of course, we don't know exactly what the planet's environment is like since it doesn't transit its star from our viewpoint, which makes studying its atmosphere extremely challenging. And even if we could, it's likely that Proxima B doesn't even have an atmosphere. These issues aren't unique to Proxima B. They are actually common problems for most planets orbiting red dwarfs, including the next one we'll be discussing. TRAPPIST-1 is one of the most fascinating systems we've found, with 7 Earth-sized planets orbiting its star, 3 of which are in the habitable zone. However, like Proxima B, these planets are subject to flares from a red dwarf star. TRAPPIST-1 is relatively calm compared to other red dwarfs, but this is likely due to its age, which is around 8 billion years. It was probably much more active when it was younger, similar to Proxima Centauri. Over its 8 billion year history, the system has likely had enough time to strip the oceans and atmospheres from any planet that might have had them, and we have evidence supporting this. TRAPPIST-1b, the first planet in the system, is likely airless, according to data from the James Webb Space Telescope, making it comparable to a super Mercury. This isn't shocking, but so far TRAPPIST-1c, D, and G also show signs of being airless, with insufficient data for E, F, and H. This is concerning for the entire system, as if these 4 planets lack atmospheres, it's very likely the remaining 3 do as well. TRAPPIST-1c might hold on to a thin atmosphere, but this doesn't change much. It appears most of the TRAPPIST-1 planets lack atmospheres, even the ones in the habitable zone. K218b is our next stop, and it's over 8 times the mass of Earth. With a mass that large, it's not Earth-like at all. To put it in perspective, it's about half the mass of Neptune, which it's likely either an ice giant or an ocean world, similar to Kepler 22b. However, K288b stands out because the James Webb Space Telescope has potentially discovered dimethyl sulfide, a possible sign of life. But this has been heavily exaggerated, so let us clear things up. James Webb did not directly detect dimethyl sulfide, only evidence suggesting its presence, and even that is not confirmed. The scientists involved never claimed they had definitively found dimethyl sulfide, only possible indications. So any claims that life has been discovered are pure clickbait. In addition, James Webb detected potential signs of a water ocean on K218b, but just like the dimethyl sulfide, this isn't confirmed either. In fact, recent findings suggest that lava oceans, not water, are a more likely explanation for the data. So while the initial excitement centered around the possibility of water, the reality is pointing towards something far more extreme. To sum it up, K218b is probably an uninhabitable super-Venus with endless lava oceans covering its surface. Even though it's almost certainly not capable of supporting life, like all the other planets we've discussed, a super-Venus with lava oceans still offers a fascinating subject for further scientific study. Gliese 6017cc, similar to Kepler 186f, does have a potential chance of being habitable. Its estimated temperature is around 30 nanodegraph, assuming it lacks an atmosphere, which makes it somewhat better than Kepler 186f. However, Gliese 6667cc's mass is significantly higher, at over 3.5 times that of Earth at minimum, and it orbits another red dwarf. Because of its large mass, it's more likely to retain an atmosphere compared to smaller red dwarf planets. But this could also be a downside, as too much atmosphere could result in Gliese 6667cc becoming another super-Venus, much like K218b. Like Kepler 186f, a very delicate balance is required to achieve a habitable temperature on this planet, which is not particularly probable. Still, unlikely doesn't mean impossible, so out of all the planets on this list, we believe Kepler 186f and Gliese 667cc have the best chance of being habitable. There are many other exoplanets that could potentially be habitable, but most of them remain uncertain due to the lack of sufficient data. Garden B is a prime example. We know so little about this planet that we decided to leave it out of this video entirely. Even after months of researching and analyzing various potentially habitable exoplanets, the conclusion remains the same. Only one planet candidate out of many truly stands out as having a good chance of being habitable. That planet is TOI 700d. We need to mention that TOI 700d orbits a red dwarf, which might seem hypocritical since we eliminated Proxima B and the TRAPPIST-1 system for the same reason. However, the difference here is that TOI 700d's star is a young red dwarf, and this youth brings several advantages to D's potential habitability. First, the star is much brighter than typical red dwarfs of its size because of its young age. This brightness means TOI 700d orbits farther from its star than other red dwarf planets in the habitable zone, reducing the likelihood of atmosphere loss or tidal locking. D also gets nearly the same amount of energy from its star that Earth receives from the Sun. While we thought TRAPPIST-1c would be Venus-like for similar reasons, that turned out to be wrong, but D still receives a very Earth-like amount of energy. TOI 700d is about 70% more massive than Earth, which makes it likely rocky, but also large enough to retain an atmosphere more easily. Its size and youth also suggest it is probably geologically active, helping it to build and maintain an atmosphere. Additionally, TOI 700d has a companion planet, TOI 700c, in the same system. C is around 7 Earth masses, which means it likely formed closer to the star and would have absorbed much of the inner system's material. This indicates that TOI 700d must have formed farther out, where planets can accumulate more volatiles like water. As a result, if TOI 700d formed farther from the star, it would have had more resources to develop an atmosphere and oceans. TOI 700d has a lot going for it. There are still thousands of different environments this planet could have, but out of all the potentially habitable exoplanets I've researched, this is the only one that we could genuinely see as being an Earth-like world with oceans and an atmosphere. However, this video serves as a reminder that just because a planet is in the habitable zone it doesn't mean it's actually habitable. Most of these planets are likely as inhospitable as Mercury, Venus, or Mars, if not worse. Habitability is highly improbable. Is it possible? Yes, absolutely, but we haven't found any solid candidates yet. So whenever you see an article claiming Earth 2.0 has been discovered, check for 3 critical details: the planet's size, temperature, and the type of star it orbits. These are the main factors that determine whether a planet can support life. There are habitable planets out there, and one day we will discover a truly Earth-like world. We firmly believe that, but we just haven't found one yet. We've explored thousands of planets, examined endless data, and while we found some interesting possibilities, none of them meet the criteria for habitability. Thank you for watching another episode of A World to Discover, and if you enjoyed this video, make sure to check out our other videos covering exoplanets and the many fascinating space discoveries we've uncovered so far.